The old man built. The old man built. The old man built. The old man built. The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality restricted from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to instead. The old man builds. The old man builds. The old man builds. The old man builds.
Hello everyone, my name is Nathan, otherwise known as Old Man Builds, and today we're going to be looking at some coils. I was having fun this morning, and I decided to spin some magnets and some coils, man. It looked really cool. It was really fun. I took a potato. You know me and food. I gotta mess with it a little bit. So I put it in a magnetic field, and I put a ball magnet in it, man, and spun that sucker. It wouldn't go normally because it was too much holding it, but then I threw in a little bit of soap, and it went ahead and spun, man. It was dude, it was fun. What's going on, guys? Hey, just to let everybody know real quick, guys, I started a podcast channel, and what it is I take all the lives and stuff that we do, and then usually the AI translations of patents and stuff. All of that is going to be on the podcast channel from here on in. That way I could do experiments on this and do the live, and that's it. So I can separate it for my purposes. So there'll be two channels. So if you haven't checked it out, please check it out. Subscribe to it. Put out a lot of shorts on there. I change it all to phone videos. So it's 9:16, so you can watch it on your phone. They won't be any regular size videos on there, just those so that you can do it on the podcast and it'll be on your phone. But yeah, that's what's going on there, man. Those are great. Yeah, they're awesome, man. Yeah, Sean's missing tonight. Sean doesn't feel well. Sean, I got you covered, buddy. Joe's going to come in a little bit. We're going to rock this thing out. So, yeah, I was kind of hoping to see some more Sean's coils. Maybe he'll drop a video or two and let me pick it up and play it on the show. But, yeah, he's got some cool stuff going on. Put it back. You know, I did it, and it rubs off. That's the problem. It keeps rubbing off. So I got to get a better marker. Now, I got a permanent marker. I put it on there. And it's doing the same thing. It's just rotating pretty fast. So, well, let's just take a look at it, man. This is it's just a little fun. Okay, here we go. Inquiring minds want to know, can you get it to spin inside of a potato? Well, yeah, if you put enough lube in it. Oh, free balling. Inquiring minds want to know, can you get it to spin inside of a potato? Well, yeah, if you put enough lube in it. Oh, free ball. Man, that's some fun humor, isn't it? You gotta have a little fun in your lab, man. I was up all night working on stuff, winding coils. I built a new coil winder, man. It works great. Got to get some work done, man. It's been far too long. I couldn't use my right hand for quite a while, so I'm able to use it now, and I'm able to get back to work. So, Yeah, just had to have a little fun. I was spinning other magnets as well. So let's go ahead and take a look. We're going to do some stuff, and then I'm going to pull up Sean's videos. He said he put a couple on Facebook Manager. So we'll check that out. And we'll start with this one, man. Let's see. Yeah, watch the volume, guys. It's kind of hard on your ears. This is my geometry coil, and it's running 180 degrees out of phase. You can see the magnet shifting back and forth. There's a lot of power in there. You can see the whole thing shaking. Pretty interesting. This is my geometry. All right, that one didn't look that interesting. Let's look at another one. Maybe it was this one. Oh, man, I picked the wrong one. I wired this coil 180 degrees out of phase. That magnet doesn't know which way to go. You know, there's kind of where it's going is in a very specific direction based on the 1 year of that coil. It kind of looks random, but there's a lot of patterns in there. I keep picking up a triangle pattern at times. I wired this coil 180 degrees out of phase. That magnet doesn't know which way to go. Yeah, definitely finding its limits. All right. We'll take a look at another one here. So everybody wants the bifilar coil to do stuff. So I made a video on that. Let's take a look at that. When you put it in the center, it finds a null zone or doesn't move at all. Field's still on. All right, this thing's going crazy spinning, right? When you put it in the center, it finds a null zone or doesn't move at all. Field's still on. But there's always a null zone right in the center. Interesting, huh? All right, this thing's going crazy spinning, right? Okay. Just a little fun, guys. Is that build on my channel? No, it's not. I did that, a year ago. But I can make another one. I go get some speaker wire and put it together. It wasn't very hard. It basically just taking like a bottle cap or something that's at least 3/4 of an inch high. So maybe like a Skippy jar or something, just anything, the cap. And you're basically just putting a hole in it, put the wire in there in the center, and then wrap it and super glue it every time you wrap. That's pretty much it. And there's a very simple wind to it. Master Evo was the one I got it from. So yeah, it works perfect. To this day, I haven't had any trouble with it. And I am pulsing everything on a DC signal, not a sine wave or anything. If I wanted frequency out of the thing, I would do a sine wave. But since this is all magnets, it's all DC. It's all DC pulses. That's it. It's just having a little fun, guys. I mean, this is pretty simple. 7.85 is what the rodent coil runs it at. These other ones are around 14. So we're real in the low hertz. Now, if you do put in a sine wave at 432 hertz, it does sing to you. All the way up to 880 hertz, it'll sing to you. So that's kind of a cool thing. Also, there's different effects that you can get. You can put the magnet in the center and get it to stand up straight based on the signal that you put in. I was using sawtooth signals, just various different things. As long as it pulsed, that magnet moved. That was basically it. As long as it had a high and a low and a high and a low, that thing would run. So it just depended on the frequency. Again, real low frequency is magnetic frequency. You get towards the magnetic end of it. Real high frequency is towards the static end, so you're not going to get a lot of magnetism. So yeah, it was pretty easy to do. Somebody wanted me to build several bifilar coils and stack them. And if I did that with, say, 3, and I turned on the center one, the other 2 would get saturated with it. I think that was the point. They could rotate magnets like that. They do a lot of different effects. They're ultimately fairly heavy for any anti-gravity effects, but they do work just great. And I like the different effects that you get from some of the geometry coils, because I want to see if I can get it to do the geometry if I put a pattern in it. So say I do 432, 538, you know what I mean, all the way up to 880 and hit every resonance point. Can I get this thing to, operate in those parameters and go around in each one of them? So I'll just come out with a simple design, do it again and again and again and again as a coil, and then find out if we can hit it. That'd be interesting. I just have to program an Arduino to do it in order to put it in there for the modulation. But I think we should be okay doing that. That shouldn't be that hard. It's only a couple of lines of code. Anyway, let's see. Higher frequency to a point will greatly increase the field range. But yes, so less magnetism, bigger range. Sine wave helps a lot if you wanted to sing. If you're in DC, you could get it to sing as well with a little bit of higher frequency. I've done that. And what we've been looking at lately on some of the channels is getting the plate to sing and get that frequency of the rotation. So RPM times 60 is your frequency. We get that frequency just right with high voltage on it, say AC flyback with a voltage multiplier. We can get a signal on there that's high frequency that'll make it sing at the same rate that it's rotating at. So we can get cool effects that happen when you do that. So that's one of my goals here, working on stuff, is to get that just right. It has to do with my Gravity Flyer project. And I'm so frustrated with that thing. I'm about ready to take off the discs and use them as Frisbees because they're garbage. And I would have much rather use a solid disc and get a lot cleaner frequency out of it and everything else instead of something that just wobbles. I mean, that's what the original one did, and I'm just not a fan. So, yeah, let's see. You have a few bifilar coils. They work great on water and geometry, 22 points. Interesting. Now, that's cool. In this way, I wanted to take a geometry coil and put it in the water and then get it to move the water. I want to vortex it. But again, at doing that, we have to create the vortex. So we have to get the different frequencies. So it has to be programmed just right. I don't think hitting it once is going to do it. Crypto, what's up, man? Oh, hold on. I got to show this, okay? Because it's got to be seen. Where is it? We were looking at the pipe on Monday. Remember that crazy pipe? They thought they were going to make all this voltage or something. I don't know what they thought they were doing. Anyway, here you go, Crypto. Just wanted to see how much voltage was in a potato. Set it down to millivolts. Stick the potato. Well, that's not bad. Look at that.
What's going
Beat the pipe. This actually registers on a multimeter. Guys, this is high school chemistry. This is not even physics. It's basically a battery. I put, an anode and a cathode in it. It's the same thing. And yeah, it's just a battery. That's all it is. What we could do with tomatoes. I did it with oranges. You guys know me. When I get to playing with all my stuff, I always got to light up the fruit. The cool thing about a potato, though, is the skin's a little thicker. I bet we can wrap the outside and maybe get some of that one-wire energy in there, in that scalar, and get it to see if it pops out, if it stays in. So that'd be interesting. But this, yeah, I win. Yeah, they can take their pole and find another rotation. It is cool, though, in a science aspect, just to see the rotation getting energy. But we all knew if you blew on the top of a pipe, there's going to be a frequency in there, which is going to create a voltage, because as soon as you have frequency, you have volts and amps. It just works that way. So, yeah, I win on the potato, though. I mean, I think it was junior high when we learned this. I don't even think it was chemistry class. Oh, all right. Let me see what I did here. Hold on. I got one that I put out, and I was just checking something. I don't remember what it was even. Oh, I think it was to see if this thing would stand up or something. Just a weird effect. It's got a Woody. Yeah. Difference between square wave and a pulse wave. It's just interesting. Now, does that have any value to anybody? Probably not. But I just thought it was interesting. All right. Hold on. I wanted to show one more thing, guys. Let me pull this up. Ben redid his lab, and I wanted to share it because it looked cool. Right on, Ben. Good job, buddy. Yeah, he's got like a whole movie thing going on, doesn't he? Huh. Dude, that was rocking, man. He's got an oscilloscope. He's got a whole bunch of new tools. Yeah, he's ready to work, man. So, hey, hats off to you, Ben, man. Nice work. All right. Let me go over to Facebook real quick, and I'll pull up Sean's stuff. There we go. So he's getting a tiny little spark out of there. It's not much. It's like barely hitting the edge of resonance. He said it doesn't work. You got something out of it, man. That's good. All right, let's go. Well, this one works. Yeah, that's awesome, Sean. That's working really well. You're sparking to your primary, huh? I guess it's going to happen when you have it seated so far in, but I don't think you could fix that. Vortex is the only one you can get it to make from. That doesn't surprise me. So hold on, let's take a closer look at it then. So what do we have here? A pyramid-shaped geometry. Then we have a vortex geometry. So you have two fields that are making counter vortexes. Well, that's just interesting, isn't it? Normally where the null zone should come in is right there between the two vortexes, but you're actually getting the plasma out of right there. That's pretty cool. I don't think he hit over 40 on that one. What's going on, John? Yeah, that's pretty cool, though. Interesting. Let's see the next one, Sean. Let's see. Oh, now you got some stuff going. Input 40 volts. Look at that. Old man knows something. That's just awesome. Imagine that coming out of your fingers like the emperor. One was from the side. This is from the top. Hey, Sean, how close was your camera to this? Well, he's getting like a DC mixed with an AC in this coil right here. You can see the fuzz of the DC, and then you can see the tendrils of the AC. Let's take a look. There's another one. Sorry, I'm just kind of going through them, guys. You're almost touching the vortex, and you didn't get those little things in your phone this time. That's cool. It needs to strike the primary coil. Okay. Strange. Huh. Ooh, that was a good strike. Something hit good. Yeah, every time it strikes your primary, Sean, it looks like you're getting more amps. So hold on, let me see if I can't pause it. Oh, come on. Yeah, you can see the white kind of in the center there. There it goes again. Yeah, you can kind of see it on the top there a little bit. Every time it strikes the outside, you get more white in it. So you got more amps in that thing. I'm trying to see if there's a great picture of it. There we go. You can see it brightens, the one going to your left on the bottom left-hand side. Yeah, you're definitely getting more amps in that one. The rest of them are nice purple glow. Then you got a bunch of white streak right there as soon as you hit your primary. Yeah, it looks like that when you hit the primary, Sean, that you're pulling more pure amps from the primary at that point. It may be going in the opposite direction, even though it looks like it's striking out. The amps might be pulling back in. Interesting. Man, that's a big coil. Yeah, we saw this one. That's the first one we saw. And that geometry didn't work. It's a cool attempt though. I give you credit for that. Man, that pyramid looks really good in there, man. You did a really nice job on that, Sean. Yeah, he's got different geometries in there. Yeah, you can see it right there too. Every time he strikes it, it gets more white. Daytime, huh? What's up, Joe? We're looking at some plasma.
Hey, everybody. Yeah, look at that plasma. Isn't this great? Looks like Sean's work if I've ever seen it.
Oh, yeah, that's definitely Sean's work. Yeah, look at that. Yeah, you missed the one earlier. Hold on. Let me see if I can't find it real quick.
Oh, yeah.
Yeah, he gets right down on it. He says he's real close to that camera, too.
Nice. Yeah, he sent me some of these videos, and what I was interested in doing was putting it through the video software and seeing if I could slow down the frame rate and kind of map it, because it looks like it looks like it has a repeating power, repeating pattern, as to the output. So
Okay.
I'd be interested in like mapping, where some of the, more powerful arcs are striking,
Interesting.
and then see if there's a sequence to it.
Well, he's definitely got repeating parts that hit. That's for sure.
Yeah, that's what I'm saying. It's repeating parts that hit, and it seems to have a directional flow as well. Like to me, that looks like, if you're looking at it from above, it's looking like it's going sort of in a counterclockwise direction.
Yeah, okay, I can see that.
Yeah.
It looks like it's doing both, Joe. It looks like it's going one way and then back the other.
Yeah, I kind of see that more at the bottom than the top of the video, which, mind you, like in relation to the coil itself, that's not top and bottom, that's left and right.
Yeah.
Yeah, but like I said, I wanted to really break one of these things down as far as the pattern is concerned, and see if there's any findings there as to either the direction of the field flow, or what's ultimately happening, and if the patterns that I find, whether or not it's consistent throughout each coil. But he's getting magnificent resonance off of these things.
You know what it could be? When you go clicking through the capacitor bank, right? You find different resonance frequencies in there, and you'll get a good spot and then a bad spot and then a good spot, and it'll continue to do that all the way around the coil. And the way the radio frequency method is you clip it at different parts of the layer all the way around, and that's where the frequency is. So if you're saying that it's hitting in a repeating pattern and it's hitting on different heights of the coil and different spots, then that would make all the sense in the world.
Yeah,
because that's the amplified signal.
Yeah, for sure. Right. And by mapping it by mapping it over time, then you could end up with all sorts of data off of what's actually happening.
I didn't even think about that, but that makes all the sense in the world, Joe.
Yep.
So we saw this one. Oh, what do you got going on here, Sean? Now he's got energy that's
right. Right. He showed me this too. The glass beads are charged.
That's what's in there. That's not fluid in there.
There's glass beads. They run like fluid because they're acting like a fluid.
That's so cool. Now that I know that makes it even better.
Or is that vapor? I think he sent me a couple. He sent me one with glass beads, and I thought he sent me maybe one with vapor. Maybe that's the vapor.
He says glass spheres are charged.
Yeah, so it's the glass spheres. Yeah. And it's very unique. In one of the videos he had sent me, and I'm sure he sent you as well, when the glass beads were still in the bag, they were actually patterning themselves, and they were patterning themselves in a hexagon.
Really?
Yeah, really.
Well, I didn't get that video. They form all kinds of patterns.
Yeah. Oh, the all kinds of patterns that they were forming though were all in sets of 5 that I saw. It was pretty neat. Like I zoomed in on it. Like these glass beads are wildly small.
Okay. Yeah, Sean, send that one. I want to see that one. Well, because most things in nature have frequency and pattern. So the fact that it's pulling up that particular pattern is very interesting. I would like to see his frequency based on the pattern as well. All right, he says I have it. Let's take a look.
Yeah, it just looks like a bag of white that he kind of zooms in on. Yep, that was it. So, I mean, I know now it's enormously difficult for me to see. So, but if you zoom in on your YouTube video, you can actually see those spots at the top of the very small glass spheres there. They're patterning in a hexagon. So you can actually see 5 points. And there's actually a point in the middle of the 5 points, but it's structuring to 5 points.
Well, it looks like they're all keeping the same distance from each other no matter where they go.
Yeah, exactly. And as you know, a hexagon is a perfectly stacking, perfectly stacking shape.
All right, let's see if this pulls in better in a different way. No, that's worse. No. Trying to make it bigger, and I don't know that I can. Let me just... Yeah, we can see a little better.
Yeah, and you see how they're equally spaced? That equal spacing amounts to, sets of 5.
Interesting.
Yeah.
Yeah, they make like a little wall pattern.
Right. It's not like a grid like a square. It's a grid like a hexagon.
Yeah. Oh,
Like
I can
an
see the
offset.
outside shape now. You're saying the outside. Okay, yeah.
Yeah, you see the very top, like above all the white, where all those little bits are floating around? Yeah.
Oh, okay. Now I see it.
But what's crazy is the way that they interact is very much like a fluid, because they have this simultaneous like attraction to each other, but at the same time, like they remain in unto themselves. So they have like a repulsive force as well that's occurring. Which is what you're seeing there, is that repulsive force, but the attractive force is keeping them together as well. And creating the structure, and therefore like they're sort of acting like a fluid.
Yeah. That's so cool.
I thought so. I never got my hands on anything like that to play with it myself, or else I'd probably have a lot more to say about it. But now I'm intrigued. That's for sure.
Oh, sorry. This is Sean's video. I sent this to Sean. Sean and I built that coil together, the one that you see all over my videos and stuff. We have people repeating it. So
cool.
It's always nice to see people getting out there and making the same coil and getting into resonate and work, because it took a long time for Sean and I to kind of figure out what was going on and what the perfect numbers were for just a regular coil for a GVS. So,
did you happen to show that video of your geometry coil spinning the magnet?
Yeah, I did.
So,
which one did...
Can you bring back up the one where it wasn't in the glass first?
Yeah, absolutely. Let me see. Yeah, it's triangle patterns is what I saw, Joe.
So that's where I was going, was an alternating triangle pattern. And that was exactly what I was hoping to see. I just wanted to see it more definite, Now, is that sphere's neodymium magnet, or is that a steel bearing?
No, that's a neodymium magnet.
Okay. Do you know if the magnetic force inside the inside the geometry coil is strong enough to get a bearing to do a similar thing?
I don't know. And I say that because the small magnet was struggling a little bit and it still has magnetism in it. You know what I mean?
No, I do. Yeah. The reason that I ask is that if you eliminate polarization as a variable, you would just be able to see the pure flows of magnetism, and where there's null zones, and there's always going to be null zones anytime you have flow. That's what a square pattern is going to create, is pulse, more or less. So you're going to have directional pulse magnetism through the geometry of the coil. So by eliminating the north-south off of the variable there as to repulsion and attraction, you'd just be able to see it catch and move, and then pause and catch and move, and pause and catch and move. That's how you would probably be able to see the pure triangle patterns, but if I'm not mistaken, that's how that coil's wound, is intercepting triangles. So
more than that.
more, I know that I'm oversimplifying it to a grand scale, but the basic geometry is based off of triangles.
Yeah, well, what's going on in that coil is it mixes up the pattern a little bit because they go off in bifilar or two different coils, right? So one coil goes off, then the other one goes off, then the one like this, right? And that's why it's moving. But it also means that it's picking up different frequency points in each layer. So
Absolutely.
if we simply wound it with the same thing, like all triangle patterns, then I think you'd find what you're looking for. It would do it perfectly.
Well, even because the magnet that you have in the middle is polarized, right? The effect that you would get in the center of that coil would actually vary, I think, pretty greatly depending on the elevation of the ball inside of the coil itself. So by elevating the ball to like a more central point where its pole would be centered with the coil would make a massive difference. And then if you go too far, you'd know it too, because there would be another massive difference.
Yes. Okay. Hey, I just want to say thank you to Sean. Sean, you didn't have to do that, brother, but I do appreciate it. Sean's always taking care of me, man.
Very cool, Sean, man. Thank you.
Thank you very much, Sean. Yeah, I agree with you, Joe. There's definitely a pattern going on in there.
Mm-hmm.
I just don't, with so many different, angles and stuff, I think we're going to have to figure out, exactly which one's which.
Well, this is another one that you could map over time. You could put a line with a directional arrow you just do that for 10 seconds worth of footage, and then you could see and actually trace exactly what it did over 10 seconds, but have it all in front of you at the same exact time, so it could start to make sense.
Okay, so this thing at the end here goes to make a triangle. I'm not catching the right point.
I mean, I saw it right at the very beginning, I remember, too.
Yeah.
Right there it was.
Mm-hmm.
With the tip of the triangle, so to speak, facing the top right of the screen.
Yeah, so when I did this coil, it was progressive triangles that's in it. So let's see. Man, I built a lot of different stuff in there. I think let me pull that off of there. Triangles, squares, God, there's a real weird shape in there. And then I think tetrahedrons, and also there's a hexagon in there. Yeah, there's quite a few.
Yeah. I mean, all that stuff too, it all plays a role in the destructive interference patterns that occur as the transmission is occurring inside of the coil structure, and that ultimately breaks your magnetic flows up into moving zones. And that's kind of the key, I guess, is the moving zones, because it's that motion that is sort of makes the flow characteristics of the coil exploited.
Mm-hmm.
Is because without the null zones, so to speak, or cancellation zones that move about in that coil, then then that acts as the differential for the higher magnetic poles that occur. So it exploits the ratio of a non-magnetic zone and a magnetic zone to a higher ratio. Making the densities more effective.
Yeah, I was saying earlier, if I take my Arduino and put in the frequencies of it, and each one as they go around, I bet you it would follow the whole pattern all day.
Mm. Yeah,
so,
I think so.
Yeah.
That's cool stuff, man. I love that coil.
Oh, that Christmas coil?
Yeah, it's very cool.
Well, now that I know what I'm doing, you got to remember that was my first coil. Then my hexagon coil was my second coil. Now I'm going to go to my third. Now that I understand where the flow is going, it's going to be so much easier to wind this thing, because I saw in the first one, there's a couple canceling fields, and I know exactly which layers they were. And then in my second one, I didn't have canceling layers. So now I know exactly how to, layer each one of them, and then the style it has to be done in. So my third coil, man, it'll just be way better, because then I know how to flow it right.
Okay. Excuse me. I'm getting a work call and I have to excuse myself. I apologize.
Yeah, not a problem. Okay, Sean's got some more stuff, so hold on, let me pull it up. Okay. He's getting plasma out of there, and he's also got those lines on his camera again. What do you call this one? Turd pie? Oh, one. Turd pie one. That insinuates you're going to make another one. Oh, you got a 90-degree coil there? Or just a rotational primary? It's so interesting. Bifilar coil to a Tesla coil. Interesting. You got some cool stuff there, Sean. I'm not doing you half the justice you need to present this stuff. I'm sorry for that. So, yeah, but that's really cool, man. You got that thing up and going. You got something out of it, because it's there for a while. You didn't probably think you'd get anything. Yeah, I agree with that. Longitudinal can be made via transverse waves, but you need to understand how to do it. It seems that even Sundew AC is DC simulated AC bias works.
Hey, look who's back.
Right on. Yeah,
Yeah.
Jarvis always says you got to get it to stand up. That's how he always phrases it.
Yeah. I used Cialis for that.
I didn't know you're that old, Joe.
No, well, it just, you know what it's like? It's like overinflating a tire, you know? They, they say not to do it, but you know, once you do it, you realize, you know, you get that nice woo on the highway.
Wow.
Yeah.
Just straight off the rail right away. Oh man. Dude, my favorite still out of all those things that are cool and scientific is just the potato. I just like spinning a magnet in a potato. It felt awesome. So
what a rebel of the science world, you know, the potato is.
I guess it's a food thing, man. Like I was looking on it. I plugged one into when I was doing my Tesla coil with the wire down the center, and I plugged it into the potato, and then I put an orange next to it with a receiving wire to a light, and it turned on like wirelessly from potato to orange, and I just was fascinated.
Yeah, man. Well, you got to remember, as cool as they are and as good as they treat you in science, they damn near wiped out the Irish. So.
Oh man.
Yeah. So it's funny. Like, I happen to forget from time to time that I have a somewhat important job. You know, like
show up once in a while.
Right. I play it off like blasé and stuff, and then I just get that phone call, and I realize that like I have a very, very large injury case that's like going to trial that I need to be able to get resolved. And I see the phone ring, and I'm like, probably gonna need to take that. You know, like
yeah.
Yeah.
Well,
yeah. Hey, listen, they know I get off at 4:30, but you know,
they don't care.
They don't care. No.
Okay, there we go. Sean wanted you to see this.
All right, let's go. Yeah. Okay. Oh, that's gnarly. All right. I don't think I've seen this one before.
No, you'll have to zoom in on the outside of that because I think there's more going on there.
Yeah, I might have to do that. I mean, I definitely see the your little discharge line, your ground line.
Right there. Because it looks like they're not just breaking outward, it looks like they're breaking in a line with it.
Yeah.
Like you can see the fuzzy discharges. You know what I mean?
Yeah.
But then in between it, it looks like it's running with it.
Yeah, I'm gonna have to play with those. After the cast, you send me this particular video, and I'll take some screenshots, and I'll try to, exploit the photo settings to try and see as much as I can out of that. That's fascinating in on itself.
Yeah,
just how it's riding the line. I think that's interesting because it's keeping that plasma field compressed enough that it's not wanting to discharge.
there you go.
Anytime it's lit up like that, it's wanting to discharge. But to hold it steady and on the outside of the wire is fascinating. That means that the wire itself is in some kind of its own. It's creating a secondary field of its own outside of whatever's going on from the coil itself. It's kind of got to be.
Yeah, hold on. You said to show this to you. So he's just got a
bifilar on a primary.
Yeah. I don't know if it's a bifilar. I know it's a spiral.
Oh, it's just okay. Just like a pancake.
Yeah. You said the other bifilar clip. I'm sorry, Sean. I'm looking.
Just so I know what's going on, is that a pancake or is it a bifilar?
It's a bifilar.
Yeah, that's what I thought. Okay.
I don't see it. Oh, just so people know, that's my winding machine right there. There's not
How's
much
it going
to
for
it.
you, by the way?
Dude, that thing is so fantastic.
That's awesome.
Dude, it just right on across. And so there were my old lady glasses looking at it going, oh, man, I should just get a big magnifying glass so I can see it. But,
yeah, well, then if you get bored, then you can just use it as a lathe.
yeah. Dude, you know what? Usually the thing was wobbling up and down as I'm winding this coil. This one's just straight as an arrow, man. It's perfect.
Love that.
Yeah, so much easier.
You know, but it's interesting because I had heard a whole bunch of discussions because like I used to play a lot, like bass and stuff, and I was into like kind of building my own basses somewhat unsuccessfully for a while. Like AK started a whole bunch of them that I never finished. That's the only reason it's the only reason it was unsuccessful, I suppose. But there's like a whole massive debate on guitar pickups about what gives the better sound, whether it's a machine wound coil or whether it's a hand wound coil, because the machines, they'll wind them perfect.
Yes.
But I guess for the purposes of a rich sound, it's sort of like the random imperfections that kind of occur, no matter how experienced you are, that kind of give the richness to the tones and stuff. I found that to be interesting. I mean, I don't think it's relevant here. I think that precision is, speed and precision is kind of king when it comes to this stuff. But from the audio perspective of things, I've heard from many people that hand wound coils always sound better.
Really?
Yeah.
I didn't know anything about that.
Yeah. I didn't either until I did.
I just see people making machines all the time to do pickup coils. That's all I see on those things.
Makes total sense. Why wouldn't you? Absolutely.
Yeah. Well, if you're into it, yeah, why not? It sets it on fire. Oh, come on now, Sean. You can't have things on fire. That's my job. I said if the balance of the coil is off, the plasma sets the coil on fire. Probably all that glue you used. That was a lot of glue.
I was gonna say, what's catching then?
Probably burning all the glue.
I mean, the plasma could be hot enough to,
Oh yeah, it is.
I'm saying to even light up the copper though. Maybe not on fire, but short it out.
Yeah.
Well, right. So that's one thing actually interesting worth saying about a short, right? We think of a short circuit, right, as just like basically an overpowering of the system leading to shorting. But what is that overpowering in the system, right? It's just bringing too much heat into the and power density into the equation that dematerializes the material that it's conducting through, right? That's what it is.
Yeah, it blows the shielding first.
Yeah.
That thin layer of shielding goes first, and then it sparks over all the time, and you can't stop it.
That's because that little piece right there goes over unity for a brief moment. It starts drawing its own energy into that one spot and fries.
Yeah, and then
it has nothing to do with what's coming down the line, so to speak, right? It has to do with what's coming down the line and then what's being drawn in at a given point and its capacity to contain it.
So I was building AC flybacks, and I learned that lesson right away. Number one, don't buy the cheap wire. Get the ones with the higher value temperature on it. That's the first thing. Second thing is you can't run them in the air. They just don't work well. You have to seal them in some way. So you could do epoxy or you could do mineral oil. One or the other, you have to do it. And if you do mineral oil, you got to pull all the air out of it. If you got epoxy, you got to do the same thing. Those air bubbles fry your coil. They create a heat bubble and they fry it. So some of those things, man, they got a whole 5 seconds out of them of use. It sparked once and you're like, yeah, I did it. And then, no, it's just fried.
Yeah, that's why in all the craziest circuitry that you have, they have all those thermal pastes and stuff, and they're wildly expensive. It's for the same reasons.
Yeah, I got a nice one from overseas, man, for an AC flyback. That thing's like indestructible, bro. It doesn't die on me ever. And I've abused the living daylights out of this thing. Yeah, well, I got 2 of them, and I still am using the first one.
Yeah, well, that works. It's always good, right? Redundancy is important when you're doing this sort of stuff, because stuff like that has set you back like weeks.
Yeah. Yeah, I actually made 2 miniature pickups, or not pickups, they're voltage multipliers. So I could do one on each side, one positive and one negative. And I did that because I kept running everything negative. And I don't know why I do it. I just run everything in negative. And it seems to work out better for some things. On this particular one, it didn't. Because I was trying to make a lifter out of it. And I made it negative, so it just sucked to the ground and stayed there. So
right. Run it backwards.
Yeah, common sense, you know what I mean? Just change the diode direction and we're good to go, right?
That's it.
So sometimes you just don't know till you do it.
That's it. Run the reverse in reverse.
Done reverse, it works. Oh.
Funny. It was one of those life hack things that I saw on YouTube one time, where a guy was stuck in his driveway because his transmission lost reverse. So he tied 2 PVC pipes like on either side of the tires in the rear, and he put it into forward, and then put it into reverse.
Nice. Oh, you know what I did do today? I took my rodent coil, and I should have filmed it, but I didn't. I balanced the capacitor bank to the coil and got it to put out a steady ring. And it was clear as day, perfect ring, got it right in the right capacitance value. That thing is 100% it's an algebra problem. It's all about balance. You got to make one side equal the other. And that's how that geometry coil works. And it's very low frequency as well. So I tried high caps, I tried low caps, and it's the low frequency caps that are doing the work. So when you go high frequency on that thing, it puts out a little bit of ozone, and it's not good for you. When you go low frequency on it, man, it starts to hum, and it just beautiful sound, man. So I should have recorded that. But yeah, it was beautiful signs all the way across. Perfect. It was ran up low, ran up high, discharge, and then did it again. So I got to catch the discharge point, man, so that I can pull it out. But yeah, it first started out, it had some nasty rings in it. So it would go normal, like a little bit, and then boom, huge ring. I mean, just a huge spike, and then come down, and then a huge spike it again. Yeah, there was some nasty stuff in there, and you had to clean it up, because then it would go in the negative just like that, and then it would start making your capacitor bank hum. So that wasn't good, because it was feeding back hard. So that's what that big spike was, a bunch of feedback, which would have been fine, you know what I mean, if I would have ran the wires to capture it. You know what I mean? I would need a bit in the middle of it in order to pull it out. You know what I mean? Just a 22 wire, and then a 11 and 11, and then I can pull that right out of the whole mix, and it'd be fine. But that was just an adventure today. I was up messing with that today, trying to get everything done, because my cold energy circuit's done, and I'm running it in cold energy, not hot, and I have a hot circuit for it. So I'm going to find out which one's better for that particular coil.
Yeah. Oh, this is like old man tinkers over here. Yeah. If you're not building, you're tinkering.
Oh, well, that's how you find stuff out.
That's it, man.
You should see all the different wires that go in different places, man. Because you're trying to think out the problem on your feet as you're going. You're like, okay, this is the ground. It has to be attached here. I need a draw in this, and then I need a light over here just to pull the draw. So you cat bank over here, and you got all these wires going every which way. Man, it looks like a spaghetti mess, but it made all perfect sense in my mind as I did it. Okay, and then it finally worked, and I'm going, oh, and then I got it to scale right up. Right, I couldn't get it. I couldn't run the thing for more than 30 seconds without the MOSFETs heating up. And by the way, I was using a ZVS to do this. Okay, so which is just a bad sign in itself. But I was determined. So they would heat up. And then I finally got it where I can push 40 volts to this thing and get it to run and stay running and not a bit of heat whatsoever in that ZVS. It was perfect. I'm going, all right. Wrote down the formula there, moved on. So, yeah.
Well,
just,
at least you remember to write it down. You know how many times I've fallen into that trap before? This worked perfect. I'm going to do it this way every time. What did I do again? You know, damn it.
That's why I started showing the frequency and stuff on everything.
Yeah.
And then, dude, I had to reset my oscilloscope. It was so out of whack for my Tesla coils because it sits too close and it just picks up energy. So I had to reset it. So,
yeah, that makes sense too.
I was getting some weird readings, man. It was like, why is this jumping around so much? And I go, oh, I know why. Let me just reset it, and it stopped jumping.
There you go. All right, that's good. Yeah, right. I mean, right. What's to stop the fields from inducing right into the pickups of the oscilloscope? Nothing at all. So.
Well, it usually sits about 3 feet away. So usually, if I got a Tesla coil, not too big of a deal. But then when you hit a massive resonance, man, that sucker shoots 6-8 feet. There's nothing you can do about it either.
Well, isn't that the whole point, though, of hitting the resonance is to start chucking the goods, man? You start chucking the goods.
I don't think that rodent coil likes heat at all. Let me just say that. From everything I ran today, it does not like the heat. That it just has too many flaws in it, too many mixed signals. It's trying to saturate the wires in a way that's destructive instead of constructive. And every time that I did it, it doesn't like it. So I think the cold method's going to be a lot better.
Yeah, you're probably not wrong about that. I'd be interested in seeing Ronin coils that just have, interestingly enough, if you were to find a specific geometric weave pattern for the wire itself that you're running on the coil. So you take multiple single strands of wire and you do a specific pattern weave on them, to kind of play right into the geometry that you're hoping for. So you kind of make it like a hybrid of a geometry coil and a Ronin coil. That would add another layer of complexity to the geometry coil because your geometry coil lays flat, whereas the Ronin coil allows for the extra access, so to speak, of rotational flow.
You think that it sits flat? It's not the field that.
Well, I know that it doesn't sit flat exactly, and I know, I'm familiar enough to get what it's doing and what it's building up. But adding another geometric component to it, I think, would only stand to enhance the effect, so to speak. And I guess how you would do that is by winding your actual wire itself in a geometry fashion.
Hold on real quick, Joe. I want to finish that thought, but Ben stopped by, so I want to show his lab. I don't think you saw it earlier.
Oh, Ben, yeah, let's check it out. What's up, Ben?
Yeah, Ben's been doing some work, man, so we got to give him some credit here, okay?
Looking good, Ben. Very nice, man.
Yeah. Look at that oscilloscope.
Very dramatic.
Yeah.
Very
Ben,
cool.
dude, that was top notch right there, Ben. Your lab looks
Oh.
awesome, by the way.
No, everything's looking great, man. Good work.
Yeah, he's got it nice and cleaned up. He's got a nice oscilloscope, man. That's what is it, 4 probes that go in there? So you got 1 frequency. So he's got a frequency generator, looks like, in there, and then 3 pickups, I think, is what is in there. So yeah, that's awesome. He definitely upgraded his lab.
Yeah, and I can't wait until he's got some good product drops and everything, man. I'll get my hands on one of those too. Get me building because it's all in one place. Now I don't have to think about it.
Yeah. Everybody likes it, Ben. Doing good, man. Yeah,
Did you wait for me to drop the news about the Daily Wire?
Oh, dude, I haven't even played that yet, Joe. I was waiting for you, yeah.
Oh man, yo, so some big news get featured on the Daily Wire.
All right, let me pull that up real quick behind the scenes, and then
Should be airing shortly.
Yeah, I don't want to get the wrong thing here, so
Yeah, well, when this thing drops, Nathan, you know, like I don't know what the chat's gonna look like then, but
here we go. All right, so yeah, you ready, Joe?
yeah, let's go.
This is wild. I just discovered these YouTube. Hey,
Oh,
folks,
hold on, I can't hear it. Is it just me?
It's just you.
Oh, you can hear it?
Mm-hmm.
this is wild. I just discovered these YouTube channels, Old Man Builds and The Straight Dope. These guys, they've basically broken physics. We're talking next level stuff. If they're right, and I think they might be, the world is about to change. Old Man Builds. He's not just talking, he's building. An actual engineer crafting ZPE devices, creating insanely efficient systems that transmit power wirelessly. Isn't sci-fi, folks. This is real-world application of suppressed tech. It's revolutionary. His counterpart, the Straight Dope, is like a philosopher-engineer hybrid. He breaks down the complex geometry and theory with insane clarity, metaphors, visuals, the works. He makes the mind-bending accessible. Together, they're a 1-2 punch of genius. Then there's Sean, retired U.S. Navy electrical engineer. This guy's building geometric Tesla coils, shaped like dodecahedrons, spirals, fractals. They're not just beautiful, they function, tuning into natural harmonics, pulling energy from the ether. It's mind-blowing. So now you've got Old Man Builds engineering ZPE tech, the Straight Dope, translating it through metaphor and philosophy, and Sean bending geometry into functional Tesla coils. Together, they're fusing energy, tech, the cosmos, even spirituality into one unified, insane framework. This isn't just science, it's a paradigm shift. These guys are peeling back the layers of reality, showing us that energy, consciousness, and the universe are all connected. If they're right, and I'm telling you, they might be, we're standing at the edge of a new civilization. Okay, folks, this is wild. I just discovered these YouTube channels, Old Man Builds and The Straight Dope. These guys,
We're on a loop.
we're talking next
I can't hear
level
it.
stuff. If they're right,
Oh. Well, there you go. Our debut. Why doesn't Ben Shapiro have a tongue? Well, if you ever watched the first couple of scenes of the first Borat, you would know that Jews don't have tongues. Listen, I'm a
Can't
half a
say
Jew.
that.
I could say that.
No. Oh man. Oh, they love it, Joe.
I
Oh,
thought it was kind of funny, you know.
I don't know why I couldn't hear that, huh? So hold on a minute. Sean said he sent new pictures. I'm looking for them. I don't see them. Nope. Don't see them in there. Sorry.
Since we have Sean watching, Sean, one thing that I'd be interested in seeing also is if you were to change the placement of your coil within the primary, you know, on to see what the induction differences would do to the effect of the coil. You know, just a curiosity that I've had.
Okay, I found them. Oh, look at that.
It's small. I think I'm missing it.
Look at the bottom corner sparking
Oh,
over.
yeah, check that. That's got standing plasma. And then it just nuked it. It's only striking the corners.
Yeah. It might be where he positioned it. Let me see if he's got another one here.
That's interesting, though. I can't explain my reasoning, but the words that are coming to mind is an offset bias. I don't know why I'm thinking that that's caused by an offset bias. But you definitely have those two corners lit up much like significantly compared to any of the others, if at all, right?
Yeah. Hold on. Let's see what we can't find out here.
So I only see two of the four corners lit.
Yeah, that's all I see too.
Right. So maybe that's why my mind is jumping to an offset bias.
Yeah, he's definitely touching the coil over it too.
Huh.
But where it sparks is different. So hold on, I'm trying to. Thing's just not giving it to me. There's the last one.
Then you have one to the left of it.
Oh God, I wish I could zoom in right now. Hold on. I'm just gonna.
Is it hitting the corner or is it hitting the primary?
It's more than that. It's a line that is putting off. So give me 1 second. Let me find that picture. Can you see it?
Yeah, it's hitting the corner, man.
Oh, it's in the corner, but look at the lines that it's putting off.
Yeah, I see that. Yeah.
So they're almost straight across.
No, they kind of like it at the beginning. It looks helical, man. You see that first turn?
Mm-hmm.
It's got that. It like inverts, and then it goes directionally right out and rides. It's riding the ridge, man. So that whole arc is actually riding the ridge of the pyramid. And each one of those lines is probably the spacing between the coil layers.
Yeah, I'm
See what I
looking
mean?
at. Yeah, I see it. I was just looking at the lines only because when John showed us, remember the plasma ball, and he was showing us the lines that layer one on top of the other.
Mm-hmm.
Then these ones come out directionally straight out.
Yeah. They do, and just in line with the winding, looks like. See how they end at a hard edge, and the hard edge is in line with the where the discharge is actually contacting the corner.
Yeah.
Yeah, so it's riding the lines of coil to only to the edge, ceases at the edge. I find that fascinating. Why wouldn't it make the turn?
I don't know. Maybe Joe, they're playing a joke on us with that pipe, huh? That had to be at that angle, but now we see the ridge of the pyramid at that angle. Now they're really getting us.
Something. You know, the direction of this pyramid also in the room may make a difference in terms of what you get to observe out of it.
Yeah, I'm gonna go back to his video. I want to see. So hold on. You know what? I'll just download it. There we go. Okay. And we'll try it a different way.
I think John Bigman was saying, like, you know, from within the pyramid, you know, and I think that's a good point. I don't know what the field geometry within this pyramid would look like as far as the toroidal flow.
Oh, hold on. It's doing it all the way. Yeah, I wish I had more time to break this down. Dude, each one of them are doing it. It won't show me it.
Yeah, if I play with enough of these images, I'll find a pattern too, man. We could have fun with that one day and then present what we find, you know?
Yeah, we're going to have
go over it together, you know? I mean, just going slow like that and jumping, you could see the flow of the plasma pattern in it.
Oh, there it was. Hold on.
That is like clearly a repeating pattern of you know, null zones and whatever, high and low density areas.
Oh man, these things, they don't want to give you the spark point. Ah. Oh, well, I'll have to pull it out later and dissect it.
Yeah. See you later, Ben. Thanks for coming around, bro.
Yeah, right on, Ben. Thank you. There we go. Okay. Oh, man, Sean's sending more images. Hold on.
Yo, Sean's good at documenting what he does, man. I love that.
He set something on fire. Oh, hold on.
Yeah, listen, we need to see the bad stuff too.
Okay. Let me you see that now, Joe? Okay. There you go.
Yep. Let me zoom in. Okay. Oh, there she goes. That's not on the corner.
Yeah. Let's just see the smoke. Hold on.
Yeah, I saw the puff of smoke come up. Oh, right. Whatever he printed that frame out of.
Oh, there. Ooh, that looks pretty.
It does.
That's awesome coloring.
The density of the discharge is by the primary, though, that's cool too.
It looks like it's coming out of that screw.
Yeah. Where did it originate from, the primary or the secondary though?
Well, on the primary, it's got those little connectors on there, and they got screws in them.
Gotcha.
So in that plastic, you can see it when you look across from it on the other side.
Yeah.
All the little Phillips heads.
Yep, that's where it came from.
Yeah, it's coming out real bright though, right away too. So it must have like a I want to say magnesium or something. You know what I mean? Like a nail would have.
Yeah.
An alloy on the outside. A zinc, maybe.
Yeah. I don't know what kind of screws they are to know what they're coated in, but because it could be any of those things. Magnesium, zinc. You know, sometimes they nickel plate the stuff. Got to pay the real money for like stainless, you know, like that's
For the good
quadruple the
stuff.
price.
Oh, so right there, I bet you, okay, in this image, if we zoomed in, we can see the tendril and it breaking in lines along with the, hold on, let me take this out of
I could already see it breaking in lines. It's just not directionally the way that you're wanting to see because it's in line with the
Yeah, so
coil
they're
windings.
yeah, they're like this with it instead of pushing out like they were earlier.
Right, because the way that we're looking at it from this photo is like the lines on the pyramid are screwy because it's at like a downward and 45-degree angle to it, right?
Oh, I was talking about
But
the plasma itself.
I'm saying, but the plasma is following those lines. I could see it.
Okay.
Absolutely.
Investigative journalist here.
Yeah, this is it. We're figuring it out live, people. Looks like some Ghostbuster shit, man. Yeah, you see that, right? See how it's in line with each one of the windings.
Yep. So he definitely got two signals going on here. He gets this, and then as soon as it ignites a spark really good, it goes the other way.
Yep. It's like lightning.
It's that
like how
compression.
lightning- Yeah.
It's that compression effect that he's got going on in the center of this coil. That's exactly what I think it is.
Yeah, but we don't like. I don't even know what's going on in the center of the coil to be real. Like, got to stick something down there.
Well, that's yeah, that's where his his number 2 coil comes out of, right down the center of it. So because he puts it in there just a little bit.
Okay. I'm just feeling like the center of the pyramid shape, the pyramid geometry, wouldn't go in a straight torus. I think that it would be segmented differently. Like there would potentially be like segmentation of the toroidal flow of the field geometry. Like there could potentially be more than one compression zone.
Oh, okay.
You see
Yeah,
what I'm
between
saying?
each one of them, yes.
Yeah. Like, I think that the pyramid, the resonance structure of the pyramid itself, I think that there would be a separation inside. Like you could be potentially dealing with a dual toroidal magnetic signature off of it internally.
Yeah. I'll be honest with you, man. It's just fascinating because it changes the whole view of the testicle as soon as he did it.
Yeah. Absolutely. It's not acting like a tube. That's for
No,
damn
not
sure.
at all. No.
And it's not acting like good old, chody humpy boy either. His other one. I like that coil personally though, man. Some of the output on that stuff is really predictable. Really predictable.
So Bernie's gonna hop on in a little bit. He'll be home in about 30 minutes. So
Very
just
cool.
stop by. Right on. Yeah. I like these coils that he's doing, man, because there's like a massive amount of just difference in them, the energy that comes out of them. And I'll be honest with you, man, I want to see both of them shooting towards each other. And I don't know how the geometry works in the primaries to get that to happen. like you would almost have to have a flat primary, you know what I mean, in order to do that. You know what I mean, to get that to work. Does that make sense to you? Because if you vertical, they're going to be like this to each other. With the other, there's a lot of geometry there.
There's a lot of geometry there. There's also a lot of things you could do with that too. Like aside from just that, like you could just the positioning of that pyramid alone could change all of the dynamic of it. Relocating the experiment location to somewhere that's more in line with the ley lines and stuff like that could significantly change the result of, you know, the experimentation.
Oh yeah.
You know, again, turning it, you know, properly east to west and stuff in terms of its flow could significantly impact the experimentation. It's just that is what I think, at least.
I agree. So hold on.
I don't know what his location looks like in terms of like significant ley lines, but it's worth looking into.
Okay, sorry, I hit the wrong button, Joe.
Yeah.
Oh man, I'm pushing buttons all wrong today. Sean's sending more videos. So
cool.
I guess this is how he's putting on the coating.
Yeah, he's epoxying it, making sure to fill in those grooves.
Yep. Charles says you're correct. Yeah, he's got it slowly turning on the rotisserie too. You notice that?
Yeah. Yeah, epoxy's funny like that. You got to put it on a rotisserie or else it gets all drippy.
Well, it self levels.
Yeah. Had my fair share of fun times with epoxy.
Okay. Joe, look at the depth. I'm going to make this a little bigger. Look at the depth of the windings.
I know, they're so deep, man. That thing's got to weigh a ton.
Well, they look like, what, a half inch in? No, maybe an eighth.
I don't know. It looks like more than that. I think he's got a pretty thin center core that these things wind around. I think one question I have on that is the shape of what he's winding around. Is it, you know, a pyramid core shape, or is it just round, you know?
Hold on, I can answer that for you right now. It's pyramid.
Okay.
And you could tell when he turns it, and we see, find it right here. You see them go up, and they're proportional to each layer.
Yep.
So he's definitely got a pyramid wind.
Sean's going to literally hate me for saying this, okay? Because if he doesn't already do this and he commits to doing what I'm about to say, I feel sorry for him.
Okay.
But every wind that he's doing, every corner that it passes, he should bend up the wire to the proper angle so it drops in the right place. You know, like for the core. So the angle is actually bent and pitched rather than just making a bent turn. It makes a hard turn at the angle. That might make a difference too for the geometry.
So wind it super tight?
Well, wind it super tight, but as you're winding it, when you're approaching the corner, you know, you kind of got to eyeball out where that corner is going to hit on the internal structure of it. And then you literally bend the wire to the angle of that you're trying to achieve, which would actually be a changing angle as with each one. It becomes an extremely convoluted, complicated process. But if you bent the wire like that, you know, that rather than just wrapping, it would become, you know, the waveform would have a whole different angle of travel rather than just a tight winding, which would bring it, you know, it would be blunted. Does that make sense? How it would be blunted with a wind.
It makes perfect sense, but you realize it's 70,000 turns.
He just said literally he would he should hate me for saying it if he's ever gonna take any credence with that.
Dude, I hate even listening to it. That's 70,000 turns, man.
I know, and it changes with every turn how much the wire would have to be bent and where. Yeah, you can't even sit there and mark it off 70,000 times without doing a hyper complicated math problem.
Yeah. Oh man.
I know. I'm just saying, I really think that pinching the curve would make it. I think it would make a difference. To be real. Yeah, guy does it, and then we light it up as the same exact thing. We're like, oh well, it was a novel idea, wasn't it?
Dude, you're gonna make Sean cry.
I know it. You know, and it's only 70,000 more bends. One more process 70,000 times.
Oh man, he's got other ones. I'll show him real quick, but I just want to say we should start doing geometry shapes. You know what I mean? Hexagon, tetrahedron, whatever you want to do, and then do them with the lines like Sean's doing, and just make sure there's like a little opening, like the size of a quarter in the center, and let's see what we get. Because then it's an open, you know what I mean? So that the plasma would have to be pulled out the side somewhere instead of it going down the center, and I wonder if it would change the tendrils coming off.
Yeah, I think it would. I wish nobody agreed with. I wish nobody agreed with what I just said, by the way. But it's seeming like the chat kind of is on board with the whole 90-degree angles matter thing. That came to my mind.
Jeez. Okay. Do you 3D print the coil winding templates? Yes, he does. 0.02 nozzle, which means it's an eternity for that thing to be done. Like, put it on in the morning, go to bed, come back the next night, and maybe it might be close. That's insane. Okay, I'm trying to get my printers to go faster, and he's getting these things to go slower. So, yeah, he's crying, laughing, Joe. He's not into that idea at all.
Yeah, right. He says it's 70,000 turns, but times 4 per bend. So, yeah, 280,000 bends away.
You're not doing that.
A little over a quarter mil, no biggie.
Oh man. Oh yeah, times 4. There you go.
60 hours to wind. Yeah, you don't want to add a 0 to that if you start bending.
Oh my God.
I'll have to will it to somebody, for Christ's sakes. Please complete.
Oh, all right. Sean's got more, so let's see it. Oh, hold on. I gotta advance the screen. No, we just saw that one. We saw this one. I don't know. It might be lagging. That's all I got right now.
As if it's not enough, man. The amount of work that Sean puts into this stuff is absolutely incredible, and we're privileged enough for him to document it like this and share.
Oh, yeah. I mean, look, I've never seen a round coil in my life, okay? Not till Sean did it. I've never seen one in a pyramid. The cones I've seen before, but never like this. They didn't have that much compression in them at all. They were barely wound on there. Somebody got lucky and, you know what I mean, got it working. But, yeah.
Yeah, man. I know. He's the man.
So hold on. Let me look. He's got more, but they're not populating real quick. So I'll just wait a minute for that. Oh man, okay, you want to see another one, Joe? Hold on. This is from Paul. He's that coil I showed you earlier.
Yeah.
Yeah, he's lighting up these, it looks like neons. Look at that. Hold on. Oh, that was cool. You realize what he's doing right there?
I got to be honest, I don't.
Okay. There's always a resonant ring. Watch
Yeah, I
the
didn't know
order.
what he was running. So
Yeah, just watch the order they turn on. It tells you how the coil flows.
oh yeah. Oh, check that. That's gnarly. Okay, cool.
Yeah, he's documenting everywhere that the energy flows at so that he can map out the coil.
Good idea. Very
So
smart.
when we do this, okay, let's see when he gets to it. And it goes in order. Okay, so right there, as it's about to go in order, every single one of those points will have a different frequency. So you can literally build a coil this small, hit one frequency, build a little bigger and hit another one, a little bigger, hits another one, and another one. That's what he's showing. So he's showing the ring structure going up the coil before it discharges.
Neat. Very cool.
It's impressive.
Smart.
Yeah. Oh, yeah. Okay. Sorry. I think Sean sent more pictures, so. Oh, there we go. Yeah, man, he does a good job glazing these things. Look at that.
Yeah, man. Clean.
Oh,
I
yeah.
always said his stuff is like, if it did nothing that it does, it would just be incredible to have sitting on your desk as a piece of art. You know, it's absolutely beautiful.
Oh, yeah. Well, they're terrifying what they do. Man, he's getting all the use out of that rotisserie, isn't he?
You ain't kidding.
Oh,
No drip. Yeah, look at the finish on that. It's beautiful.
Oh, that looks like silver in there. Hold on. Let me just pause it. That's a silver winding, Joe.
Oh, yeah?
You see it? The color?
Hang on. Oh, yeah, look at that.
So he's got a copper winding and a silver winding of the same size.
And what's the difference in, you know, what he's seeing out of it?
We don't know yet.
Oh, I was going to say, I don't think I saw those.
No, we haven't seen it yet.
All right. Well, this is why the shows continue.
That's just so cool that he did it. Now we have an idea. He said, yeah, it's silver.
Very cool.
Let's see the next one. Oh, here's Lumpy.
Humpy
Humpy.
to chode. I really like this one because this one has like a mappable pattern that it throws out on the breakout.
Yeah.
Which I think is super cool. This was also the one that was discharging like the helical tendrils, which is, you know, kind of speaks for itself.
Yeah. Dude, I like this one. Yeah, Sean said he's gonna. Okay, let me tell you my diabolical mind here, Joe. He says he's gonna build me one of those spheres, right? And we saw all the plasma puts out.
Mm-hmm.
I'm literally gonna take coax cables, okay, and I will run them from that sphere. I'll put a little harness on my back and I'll run them out my fingers, dude, and I'll look like the emperor. I'll put on a big old hoodie, you know what I mean? It's nice and open, you know what I mean? Like, dude. Because those things are not as bad as regular voltage, hopefully. If he's getting that close to the camera, usually it's hot. You can feel it. You don't want to be near it. And it puts static right next to you, right?
I was going to say, not to mention, like, if he's going that close to it with the camera and the camera is not, distorting either the sensor in the camera, then you should be a-okay.
Yeah.
Like
Or-
that camera sensor is really, really sensitive to electromagnetic stuff. So, you know, it doesn't take a lot to trip them out.
Yeah, I'm excited, man. I want to see how it works. I'll try it with a safety glove. You know what I mean? Test it out, see what it does, and then just blast it once and hope the camera doesn't die on me.
I don't think it will. I think you'd be all right.
That's gonna be so
It
cool,
doesn't
dude.
sound like the smartest fucking idea I ever heard in my life, but I mean, hey, listen, it's, you know,
Hey, it's what Old Man Builds does, dude. I
It's
try
science.
it and find out. Just
it'll make
like
a hell of a
Sean-
video.
Sean goes, we were watching back that tape when Sean and I were talking about my first Tesla coil, dude, and it was literally smoking, right? So I go over it and I go, oh, look, it's smoking. So I go over there and I took the voltage and cranked it way up. You know what I mean? Like, oh, well, let's just find out how much. So, and
You have to hook the other end of the coax cable to a burrito, just for good measure, you know.
I'll put the burrito right in the center ring. I'll just put a burrito right there and I'll cook my lunch.
That's it, man. Hey, listen, ain't nobody love burritos more than me, except for this man.
Oh man, you know, I just think it's hilarious. People, you know, talking about all that science talk, and I'm over here lighting up burritos. It's just hilarious because they're not doing much different stuff that I'm doing, to be honest with you.
Yeah.
Oh, all in the name of science. That's right.
I'll tell you what. I caught that episode of Ashton with Sal Pius again the other day, and I'll tell you what, that was I think probably one of their best interactions that they had. You know, because you know, Ashton as usual, he can't word around Sal. You know, he knows where not to go, but he will tell you, you know, say that some of the quiet parts out loud, just as long as it's like not asked and not in context. You know what I mean? If it's disconnected from a question and it's disconnected from the relevance of whatever, you know, the quiet part
you
is.
noticed that too, huh?
Oh, absolutely. Like,
Yeah,
especially when he started playing with all the Planck scale stuff, I was like, oh, all this stuff sounds familiar. Sounds like Old Man Builds
Yeah.
getting on there with the straight dope. You know, that's what that sounds like to me.
Oh yeah.
You know?
So it was like usually Ashton goes for the kill and goes for the question, and then you see him just stop dead in his tracks and won't go there. And I was thinking, man, this is frustrating, but I bet it was one of those things behind the scenes they got on before and said you can't go there.
Absolutely.
Because as soon as you said Planck scale, okay, and he told you that you had to force it into the center, I mean, dude, it was game over. I have it. You know what I mean?
Well, what got me about that, and it's like, I'm not one that ever feels the need for like any sort of great validation from external sources, but it always does feel good when you hear the things that you know to be inherently true and that you share with other people. When you hear somebody that is kind of perceived as an authority on the subject matter, you know, and they're saying what you've been saying all along too, that you've had your own personal experience with, and that was to do with what happens when you get on the other side of the Planck scale. Once you cross that bound of the Planck scale, he straight said, he's like, well, I mean, time and space collapses, man. Like,
well, hold on. He said an important line in there, Joe. And
yeah, I wish I would have quoted him because the way he said it was spot on. That's what resonated with me.
Yeah. So when you start pushing into the Planck scale, it pushes back. So when he said that, just understand this. I run my Tesla coil. It only goes out in light 3 feet at 10 volts. When you get to the center of it and you push that out, it's 5 feet. But it's compressed in the center to the very smallest scale you can get it. So I pushed it into the Planck scale in order to get it to expand out the field, right? That's why I keep saying it's like nuclear material, man. Once you compress it, boom, it blows out just like that. It's exactly what Sal said.
So let me wrap that back into a nice little neat package for everybody. So if we know that it's going to push out at an extreme level at that point, but it pushes back, that means it's in a state of expansion and compression simultaneously, which is what is cavitation. So
that's exactly what it is. That's what I've been saying.
Right. So go full circle with it is what I'm saying. Right. So you have something that's indefinitely expanding and then also pressing back and fighting it, and it's in a pulse state. It's in a pulse state of cavitation. That's what the sustained reaction is.
So let me just say this. He said, Dan Winter says this as well. Let me tell you, I show it. I built it in my coils. I've shown the field. Okay? There's no getting around it. Yeah, I have it. And I know exactly how to build it. So
now what happens though when you don't have it in this contained pulse, when you just get an expanse, is you get a cascade effect. That cascade effect is whatever's running the reaction will melt down, because your whatever your system is comprised of just simply cannot stand up to that level of energy density. So it has to be in this state of expansion and contraction, because it's that collapse that allows for it to be sustained.
Well, it's also why it comes out thicker on the outside than it does on the inside, because it feels like it's, when you're running it, it feels real thin and pliable on the inside, but when you get to the outside, it feels thick and heavy. And it's just an experience from standing in the room, okay? But you'll know the static electricity doesn't jump the field. Because you see me, my computer goes off, man. I can show you a video. This thing, man, was lighting up like a Christmas tree. Okay? It won't do any of that at the same voltages. It just stops it dead in its tracks. It won't let it go. That makes sense,
because it's literally an event horizon that you're dealing with. It's literally an infinitesimally small event horizon that you're on one side of it, then you're on the other side of it. Now, where it gets like a real nasty son of a bitch is if you were to hit it dead on. See, I don't want to say it's an impossibility, because it's not, but it too is a diffuse on either side of the line.
It's, if you build it right, you can create plasma out of the forcing the two together. It'll start creating plasma. That's the thing. Translucent plasma. But I've never gotten it that high. It always held it in when it looks like an invisible field. So,
but okay. So I'm gonna hurt your head with this one.
Go ahead.
Is it a translucent or transparent plasma, or is it just not here? Get it?
Yeah.
You know what I mean? It's not that it's translucent or transparent. It's just not here.
That's possible.
It's there on the other side.
because it crossed Planck's distance.
That.
Well, you're probably right. I can tell you, I've been saying this for the last year, by the way, on exactly how this field works. So, yeah, it definitely works that way, and they're definitely seeing it now. And Sal says it word for word as much as he can. What's really going on here and what he's looking at. I have it.
It's the super force, man.
Yeah, well, I have the super duper force, man. I got it. So it's just incredible, because you can make it like Gravity Fire does it, Geometry Coil does it. Matter of fact, Geometry Coil was born to do this. So much better, man.
What's going on in the chat? All sorts of stuff.
Oh yeah.
Yeah. Toy Maker, you're right as usual. It all is Steinman's. But even I'm pretty sure Sal has said that at a time or two. I don't know about in that last episode, but he's attributed Steinman's as well to his work.
Okay, I'm going to disagree a little bit.
Okay.
And it may be in what Steinman's didn't release or wasn't able to release by GE. but it is not in the papers that he did release.
Well, his work was definitely geared in that direction. It just maybe it never reached in his published work where it had to be. But
you have to read between the lines on what he crushed out of everything to get it to run the way he wanted it to run. That's really what it is. Okay. And if you can read between the lines and see that, yeah, but he didn't flat out say what it was. And I don't think they let him do it. I don't think that he didn't know, because I think he did know. I don't think they let him say it.
yeah, it's true. Well, mind you something too. Stefan was just saying, right? Might be right. Scalar dimension, right? And that's sort of the point. There's something on the other side of all this, which we've covered in exhaustion, every way that you could say it, from the spiritual end of things to the consciousness end of things to the electromagnetic and reality end of things to the engineering end of things, and what it culminates to is, like you said, translucent plasma, right? It's the same exact thing. It's just not here. It's just there. And there exists. There's where we're pulling all this from. There manifest in our reality, just in all sorts of different ways that we're discussing. And this is in the electromagnetic spectrum of things. And that's how it manifests when we pull it into our dimensionality. But our dimensionality is only one portion of a much greater whole, right?
Okay, so let me just, I'm sorry, Joe. Let me just say this, because I was so frustrated after listening to the Ashton interview for one reason. Okay, they're confusing fields. They don't realize the static field and magnetic field are on the same level. That it's the same scale. It's just different frequencies. So when you create a radiant field, it's a different field. It's different altogether. It's not building like a static or magnetic field. So they keep saying all the time, magnetic. Magnetic is too strong for this. It has to be the weak force. So just understand this. Frequency, static, radiant gives you gravity. Okay? It's the weak forces. It's not the strong forces. Magnetic is a strong force. Therefore, it's the wrong answer. And everybody keeps saying magnetic because they have this drilled into their skull the wrong way. It's minute magnetism.
All it is it's a different manifestation of the same energy in a different density and flow pattern, right? So that's what it comes to. So whenever you're talking magnetic, you're talking about spiraling flow pattern. It's that spiraling flow pattern that is the mechanism of the magnetic force. If you're talking electrical, right? We talked about this when we were talking about scalar. It's a diffuse vector propagation, right? So you have a directional vector of emission that's diffuse over distance, so to speak, in terms of what we're talking about, I guess. But if you bring it either inward or outward, omnidirectional from a source of emission, that's when you're in scalar. So what's the significance of scalar? Well, scalar, the fact is that because scalar is vectored omnidirectional, either outward or inward, that creates an easier thing to manipulate into either a magnetic force or an electrical force, because it's both electrical and magnetic in its initial composition. And like you could create a pump out of it, because it's outward and inward. So anytime you have something at an expanse, and anytime you have something coming in, that's going to create, there's got to be two sides to it.
Okay, but here's what I'm saying. Okay, this is why it frustrates me. Sure. I can literally take a magnetic field, right? I can turn the frequency way up. What happens? The amps go down, the volts go up, and it goes into static.
Yep.
Then I could take the frequency and shove it way down and get a big magnetic field. They are the same. Okay?
They are.
But it
Absolutely.
depends on which side of the scale you're playing on. Radiant energy is radiation. The
Mhm.
radiant is the low side, radiation's the high side. Okay? That's what it is. Because it forces it in on the Planck scale to push back out, it becomes radiation on the outside. Radiant stays in. Okay? You see the difference? It's the two fields is where you got to match it. You cannot take a static field and have a magnetic field hold it in. They don't work. They mesh. They just mesh.
Right.
And
Well, they're right
that's where
because
they're not seeing it.
well, they mesh because the flow pattern of the magnetic field is going to fuck up the pattern, the non-patterning of the static.
Yeah, but that's the whole point. You cannot build a field bubble with the same types. You have to have different types. You're meshing. It's interacting. You want a non-interacting where it's forcing the bubble in. That's the biggest difference there. You're blowing it way out of the water when you keep saying magnetic.
Compression and expansion simultaneously, not it canceling itself out.
Well, that's what I'm trying to say. In the testicle, when you force it in, you're hitting the Planck scale. Once you hit the Planck scale, it forces it back out, and then it creates a second field. You don't get it without it.
I'm on board. I'm not getting an argument from me out of that. What's up, Bernie?
What's up, Bernie?
Going. All right. So,
I love that.
So
I love that.
I know you do.
And so episode.
I had a epiphany of when you realize you're an old man and no longer young is when, all right. The thing I now hate about high school girls is that they stay, or I get older, but they stay the same age. It's like, shit, I'm too old now. All right.
All right there, Quagmire. Relax yourself.
Hey, I ain't doing no giggity. I'm just saying, all right.
Man, I miss you, Bernie. You're a good dude.
I'll see you next Wednesday, Sean. Real quick, he had a coil he wanted to show you guys. I want to put it up real quick. So is that it? No, might be that one. No, sorry, I'm playing with this. Which one is it? It's that one.
Look at that glow.
See, that's got a whole different thing going on with it, man. Look how straight those tendrils are.
The tendrils look like they're rotating too, like it's a vortex.
They are, yeah. If you're looking at it from the top down, this one is clockwise.
I think that's the silver coil.
How straight those tendrils are, though, is wildly fascinating to me.
Yes, it
love
is.
to see them up close.
Which way is the coil wound, clockwise or counterclockwise? Do we know?
I don't know.
Sean, if you're still there.
Look at that. It's straight out.
That's what I'm saying, man.
So this is the silver. Oh, and look, it's a vortex around the what do you call it? The spires, right? Like,
yeah, there's one shooting right down the center, and then the vortex goes right around it.
Hold on, let me zoom in on this. Oh, this one has the most clear helical pattern of them all, man. Can you zoom in on that?
It really does.
He says first test the silver.
So, like, what's crazy is like, and it's caduceus in its nature because it's got a center rod running right up it too.
It does. That's wildly fascinating.
Yeah, very, very cool. Sean, if you can send me the video, but if you can get clear like photos, like at like a high speed, shutter speed.
Smooth as butter, he says, and this is from the silver coils. Like, these are some fascinating first initial results of differences with the silver material as opposed to copper, right?
Absolutely.
That's
Big-
totally different.
Huge difference.
Huge. Now I want to see gold.
Yeah, well,
Who's gonna fund it? Who's gonna send Sean several kilograms of gold wire? Come on.
do we know? Like, I mean, seeing as what the frequencies do as they run along the wire. I mean, is 24K plated enough if it's a nice thick plate?
Mm,
Because that would make it a lot more attainable.
yeah. Well, he said this is almost perfectly silent.
You saying this
Wow.
is 99.9% silver? That's epic and amazing.
Hey, Sean, how did you coat the silver so it doesn't cross over to one another? Was there a coating on it? It says 3,000 turns.
Sounds expensive.
Oh, it was.
It's an investment that will survive any market crashes and gain value, right? So why not?
Yeah, just busted out the epoxy and call it a day.
No, I think that's what he did. So, you know what it reminds me of? When you look at the Anunnaki and they're both standing there with the wings on it and they have the structure in the center that looks like the bush, but they always call it the DNA structure.
Yeah.
And the tendrils are going around the line like the DNA. That's what it reminds me of.
Quite a bit.
Yeah.
Oh, looks like a unicorn horn. I think you found your unicorn, brother.
Yeah, somebody was talking about that. I'm trying to think. One of the guys that knows Sal Paez was talking about it, who did the interview about the cold energy. And he did a really good job. I can't remember his name, though. A bigger guy.
The Dave? No.
Yeah, I think it was Dave.
Sounds like Dave, yeah. I was gonna say.
Yeah, he did a great job on that interview. But he was talking about this too, about the line down the center, how it shows up that way. So,
Right? So many correlations.
I think we're going to end up finding them all, Bernie.
Oh, that's the goal.
It'll take some time, but I think so.
Yeah. Dude, that's definitely awesome. Let me see if he's got any more on there.
I'm fascinated by this one.
Look at that. That's how he did it, Joe. He's got that big cavity in the center. But you see the rod that he puts in there goes down a little bit.
Mercury.
I see that, right.
Try it empty, then try it with mercury in the middle and see what happens.
Get some weird stuff happening.
You guys are way more adverse to mercury as I am than I am, like, generally. Like, I've heard Nathan naysay it a whole bunch of times, but I was an irresponsible child with a whole ton of liquid mercury.
As long as you don't oxidize it or turn it into nanomaterials, then it's like it's not as harmful as they make out. But as soon as you do, it actually turns to be like exponentially more harmful than.
Well, once you start running current through it too, you start
that's where
running
you have
into the
oxidization.
vaporization of it, and exactly.
Look,
those are your nanoparticles right there. That's the problem.
Let me tell you, that's the problem. That's what they want to see happen. They don't want me just to have mercury to put my finger in it, okay? Because that'd be fine. They want me to take mercury and run high voltage through it.
Other elements into, right? That's another key part of it.
Well, contain it in, just contain it in plumbing, and then it's fine. Because it's not going to be under pressure; it's going to be under flow.
Well, I didn't see a whole lot of flow in that coil. Did you? When it comes to that, it's going to be in one spot.
Doesn't have to be in that coil. It could be, you have a whole assortment of crap to work with here. Runs the gamut, brother. You got it all.
All right, Sean wants to see the pyramid coil again. Hold on. I think he's probably got a point to make there. It's like two pyramids in one, like the top part of the pyramid and then the bottom part, right?
The capstone.
I feel like a glass sphere would be very cool to put some liquid mercury in and start to do some stuff with. I'm just saying.
Right?
Throw my throw my hands out, you'd be able to see what it's doing. It'll be wish-washing around. I promise you
Anyone
that.
out there who wants to send me mercury to start experimenting with, feel free.
I don't think they can. They get in trouble. I think they sell it though.
Yeah, I was gonna say you could buy it.
Yeah.
For over inflated prices. Or
Oh yeah. That
anyone
always is.
knows of an old stash somewhere, because like thermometers, old devices, and like old school, like, or it's like science, like depository stuff like that, where they just have it laying around, and there's lots out there.
You know
Yeah.
what? Oh,
You could start crushing up some Cinnabar too if you wanted to. You'd probably get that cheap enough.
you know what he should do is take the inside of this thing and just fill it. When he's doing the epoxy, fill it. Because now it's going to force out that field and won't let any of it in. So it's going to create a tremendous amount of heat on that coil. And it's if he puts it in DC, it'll force that field way out before it sparks.
Sean's asking,
I just feel like, you know, with the discharge that looks like that, though, that there's got to be like the inverse happening, right? So wherever it's sucking from, if you fill it in, it might mess with the internal field structure to a degree, especially if you fill it. Well, I think resin's kind of like a semiconductor. I don't think it's a full-blown insulator.
Yeah. By the way, I agree with this guy here. He should get somebody out there to take pictures, professional pictures of it. If they can get the camera to zoom in beautifully. I mean, that's wall art right there, man.
Yeah. Like a high-speed camera would capture that really good because it's so bright, and they usually dim the, you know, each frame down so much because it's capturing it so fast. That would photograph amazing in high speed.
Have to set him up with Tim Ventura, who's been doing that a lot lately, I believe.
What was Tim doing?
Has the new photo equipment and taking high resolution, high speed photos of different experiments and whatnot. People.
Well, you see, that would be awesome to have Tim visit Sean.
Absolutely.
That would be amazing.
Where's Sean look? Or we'll talk privately afterwards. Don't need to let's
be doxing our people there, Bernie.
Yeah, exactly. Talk private after.
You're safe. Nobody's going to Canada for you, bro.
Until America invades and I'm the 51st state.
No, we're not going to invade you. We're just going to bankrupt you.
Well, bankrupt the rest of Canada, and then Alberta will separate and join America, and I live in Alberta, so.
Yeah. No, I heard Alberta's about to be the 51st state before any of the rest, so.
Exactly.
Yeah.
They might even trade California for Alberta. You never know, right? Like Joe becomes or Nathan becomes Canadian, and
yeah, wouldn't that be ironic?
Is that before or after they take us out with tsunamis and earthquakes?
Oh God, we want to prevent that one.
Yeah, they already started. Like last year, I think. Not only last year, I think it was a couple months ago before they had all the fires. They had a tsunami, and then they had, or maybe not a tsunami, or something else.
It's crazy shit, man. California's just straight up fall into the ocean one day after it sets on fire. It's like literally terrible.
Yellowstone's gonna go off, and we're all done.
Yeah, I'm screwed too. If that happens, let's not have that happen.
I don't think it's gonna. It'll be okay. We'll hope for the best.
Oh, hold on, Bernie. Sean wants you to see the pyramid blasting off. Hold on.
Yes, please.
A second.
Oh. Interesting. Is that like a cone glow around it? Like, almost seems like it's got its own like field that.
Look at that.
Oh, never mind. It's that.
Yeah, that part.
The dish. Okay, I see.
Yeah, it zapped over.
No, we paused it at a couple spots. There was a few of them. It was hitting the corner, and then one of the others, it was hitting the primary.
Yeah, I see that there, right there and there.
Okay, it's glowing 90 degrees corner because there are vortexes there. That's
Right,
what Steve
like
says. It's interesting.
very much so.
Well, that means that if it's opposite and there's high energy density at those two opposing corners, that would mean that there's probably very low energy density at the opposite two corners. You know, that's just a assumption, but given the output, the breakout patterns appear in that same form, where you have constant hot spots, constant voids.
I have one suggestion before we continue for that setup, Sean. Instead of it being a round dish upside down inverted, to do a triangle or a square pyramidal one going up around the pyramid in the center, if that makes sense. The outside coil. To make both coils pyramidal.
Yeah, I mean, something similar to that I was saying before, which is you could just, the configuration, you could just move the distances and change the configuration of the coil within the primary and yield wildly different results depending on those interacting geometry patterns that are being put off by both the primary and the secondary.
The horizontal alternating spikes are quite fascinating.
Oh, there we go. Okay, hold on. I
Oh,
think this is the one Sean wanted. This one's from the top view. He says he's right close to it, Bernie, with his camera.
Wow. So it's like, that's like a cold, not hot, and that's the potential sort of like purple plasma that legendarily heals people, if I'm not mistaken.
If it's,
Yeah.
you know,
Oh, interesting, Sean. It has to be round for the outside coil to work, eh?
The most pain in his backside coil.
Oh, I'm sure you're gonna find a new one that's even more of a pain, but
He says it strikes his phone, and it still doesn't
What?
break your phone.
wow.
what I wonder is in the atmosphere, just in regular air, where it's reaching out and it's, you know, reaching its furthest point. At some points, it's looking like it's splashing a little bit, and I just wonder what it's splashing. I don't know, like a better word for that. Do you see what I mean?
Mm-hmm.
It's
Yeah.
like the equivalent of a
EVOs.
strike.
It's splashing EVOs out of those strikes.
Yeah, right. Could very well just be like little plasma clusters,
Yeah, little exotic vacuum object coming out of it.
which is
Look-
weird because that would just be the same as like the cold side of static, if you're thinking about it. Because this is hot, but after it discharges, just like an arc, it could change to the opposite, the inverse of it.
Mm-hmm. So look at the glue where you put it on, and when it strikes it looks like clouds with lightning.
Right?
That's where I was going. That's what I was
Yeah,
referring to as like
EVO
a
aspect.
splash. Yeah. And Bernie's definitely, now that I'm thinking about it, Bernie's definitely right. It's right. It's Evos. Like little Evo clusters.
And those specific contact points, you'd want to check out eventually under a microscope because get samples tested because there's good chance of transmutation happening in those interactions.
Yeah, cavitation pockets with transmuted, copper at that point. But I don't think it's hitting the copper. I think that's in air. So that's where it's problematic.
The epoxy or whatever it's touching, contacting, right? Whatever matter it contacts that the EVO then comes out of is where you would get the reactions of small transmutations.
Well, if you recall, Gerald was having the bubbling problem with his epoxies and stuff, where micro pockets were forming right along the wire
Yep.
strands where he epoxied over it. And it was all just evocavitation events.
Absolutely.
But
Look at
what
that.
I'm saying is, I don't think that this breakout is actually contacting anything. I think it's just an air. So the following what you're saying is going to be difficult because there's no record of it, so to speak.
I think the contact is where you get the flashes.
Yeah.
But it's not. But it's not with the copper. It's with the plastic or the coating or whatever. I had seen of it.
Is there any clarification on that? Is it an air or is it on material?
Well, he said he's going to take it and look under the microscope and share results next week. So
There you go.
find out real science.
Yeah, just compare it to a fresh piece that's never been in the field. You know?
It's like lightning in the fact that it doesn't flip the field to hot.
Mhm.
You see the white and there's hot. It always stays purple until it makes contact with the glue. Then it turns white hot. You know what I mean? Just like lightning. Until it hits some mineral in the atmosphere or something in the cloud, then it'll change the lightning.
Yep, that's how that works.
That's so fascinating. I could look at plasma all day, man.
I know, right? It's just so mesmerizing, and just Sean, you're like, I know why you do it, because it's like you can stare at it for not minutes, not hours, not days, not weeks, but your whole lifetime, just because it's that fascinating, wild, and beautiful.
Yeah, Bob was showing it today. Greenier was showing it today
Yeah.
in a vacuum chamber. That was pretty awesome.
It was
Very cool.
And he had little, what was it, little plasmoids or something forming on the outside right there. They're forming little balls. And then you'd see it spark over every once in a while.
right? Like,
It's funny, like the way that ball lightning kind of works, like and moves and stuff when it's self-contained, reminds me quite a bit about like what we were showing earlier with the glass beads. You know how they arrange, but they move around. They're sensitive to its environment, and they kind of are respondent to the environment. But like at the same time, because they're charged, there's a form of like order between it. You know, like, and that's sort of what was being exhibited by the glass particles as well, to a degree.
Yeah. Yeah, it was neat, man. Anytime they vacuum chamber or something like that, they're creating negative pressure in there, and that's what's forming the little, evos in there to go like that. And you see the radiant coming off of the actual bulb at the end. It just looks like it glows, and it looks like they pulled the negative on the cylinder that was on the outside, and then put the positive to the thing going down the center, so that it pulls the field out. Most of the times they'll just take the outside of the container and make it negative, and then the inside gets it, so it makes a star in there. So you can put different shapes and stuff like that, and it comes out in plasma. It's gorgeous to look at.
Mm.
And I, as an alchemist and just personal experience, do truly believe it is alive. Like, just on another level.
Oh yeah.
I think that it's life force energy, to be honest. Plasma's life force energy.
For sure. No doubt about it in my mind. And then it's like, what happens when we connect AI to plasma?
Well, then you probably have a sentient AI. Probably.
I think.
Right?
So, Bernie, what projects do you have going on, man?
Lots of different things on the go. I'm currently going to be wrapping some titanium wire maggrav coils and triple solenoids coming up,
Nice.
as well as starting to experiment with a new actual power source to start varying the amount of electrical input going in, and some of my electrolysis experiments. I've got a bunch of other things I'm not quite ready to talk about publicly because kind of need to make a little bit of a dead man switch so I don't just get disappeared because, you know, water powered cars, they don't really like it too much. But besides that, I've got an upcoming interview with Bob Greenier and Jeremiah to discuss Jeremiah's replication of the aluminum transmutation into iron sphericals through acoustic energy, and then also reached out for scheduling with Malcolm Bendall for an episode with Malcolm Bendall and Bob Greenier together as well. So,
Oh, that's epic, man. Nice.
Yeah.
got
I'd like I'd probably give a piece of me to talk to them about Thunderstorm, man, because like that was like so critical in me getting my head around any of this stuff.
Yeah.
for sure. Yeah, and lots of epic stuff just going on all over the place, and trying to catch it all and make sense of it all and bring it all together the best we can. Yeah, let's see. What
Nice,
else?
man. Sounds like the world's really your Pokemon,
coming
man.
in the summer too. I'm just trying to figure out. Gonna make it to at least 1 or 2 American conferences this summer, and actually travel. Just trying to figure out all the legalities of it with the issues of the changing world political environment and all, and how shanty the Canadian exchange rate is compared to America. But hey, at least working every day and trying to make it happen.
Nice. What were you thinking about making it to, if you can?
Most likely Tesla Tech in Albuquerque, New Mexico there in August, and depending, I think it's June that Cosmic Summit happens.
Summit, yeah.
So I'm gonna try to make it there.
I've been wanting to make it to Cosmic Summit too, man. I think if anything, the people that we deal with on the regular, we should all try to make it to Cosmic Summit. You know, it's in North Carolina.
All right, absolutely.
Yeah.
Yeah. Let's see. I guess that's enough updates for right now. Putting together a couple good presentations as well on my work with Sir Isaac Newton's 7 colored states of transmutational metals, and eventually hope to publish a paper on that here.
Very cool.
Very cool.
Yeah. But we got to, so you said next Wednesday you got Sean coming back on for this, so would love to try to make it on and join for the second half of that or something, and ask some questions and connect all the coil knowledge, because there's so much with coils. And hopefully this Friday we can all connect with Gerald again and Mike, and talk some more on what they're doing, because we're reaching this critical point where everybody's just starting to feel comfortable enough with sharing some of their discoveries and secrets without fearing to fully disappear, and that it's all going to be stolen by different governments. And it's about open sourcing it all, and just a catastrophic level of disclosure and proofs of concepts coming out all at once. That, you know, it's too
You really think he's gonna disclose it?
Well, I'm saying, like, you know, all of us, you know, by the end of the year, hopefully we'll put it all out there so that we can really jumpstart this new technology breakthrough and actually have, you know, levitating crafts and anti-gravity, and that it is actually anti-gravitic in the engineering aspects of it, and understanding it, and the spin states of how you align things and the fields. And yeah, there's gotta also get Keshi on, which I've been putting off due to the political climate with Iran, but it's only going to get worse, so it needs to happen. And yeah, that one is going to be a little controversial, but there's information that needs to really come out for sure.
Yeah, I mean, there's always a chance too that, any of the conflicts that kind of lie ahead of us through all this may end up forcing some form of disclosure anyway, because like I'm pretty sure that everything is ripe to just use it. I don't think that, the administration really is into a long-term boots on the ground conflict anymore. I think it's just more get in, get out, do it dirty. And, I think that there was probably elements of this just already at play constantly.
Oh, definitely.
That is just, yeah, it's just part of like the normal battle tactic at this point. And, but the more prevalent that it's used and the more widely that it's used, the harder it becomes to really, keep it quiet. Sort of what it boils down
and
to.
a big part of that is the like the EWEM weapons, and I will be doing a episode or two covering all of my past interviews with Eric Hecker and what he's disclosed, leading up to a new interview with them here in a few months to fully get it out there. And the collaborative evidence that Dutch Sense has documented and shown in monitoring all of the different, well, I guess, satellite imagery and like just warfare stuff coming out of Antarctica and the different systems. And yeah, it's wild. And it's like, is that why we're seeing a bunch of earthquakes in Iran and Myanmar, China, North Korea areas these days, right? Like,
I'll share. I caught just like an operations kind of debrief on something that they were running recently with the U.S. Navy and in Yemen, and I know that the narrator didn't even realize the extent of what he was saying, but like they were talking about the F-18 Growlers, that they run. They're jammers. The U.S. Navy has the Growlers are all jamming planes, and they send them ahead of like other F-18s and F-35s just to make sure that the radar and surface to air stuff is sort of like kept at bay. And they were talking about the new generation jamming pod. And what they were saying is that they were like, okay, and they were effectively able to jam and disable, all of, the different satellite arrays and radar arrays that they had, to clear the way. And then they went into the destructive element of it. And I was like, wait a second, they showed them outfitted and all they had was the jamming pod. They were so they're literally collapsing the radar waveforms and then sending them back to where the hell they came from and overloading their system with radiant scalar energy and blowing them up that way. So if that doesn't sound right out of 85 Bearden, they didn't say the quiet part out loud about how they were doing it, but how do you jam a signal and literally physically destroy a radar array without a shot being fired? That's how. And that's what their Growler pod's doing now. So it's already happening.
Just want to say real quick, hi Lulu.
Shout out Lulu, shout out Jessica, lovely ladies in the chat. It's always good that there's some women out there, not just men, interested in this. I know it can be dull and nerdy, but everyone's intelligent. It's just what you choose to apply yourself to.
Yeah, one day somebody will appreciate that. from the opposite
Yep.
sex. One day.
Right on, Jessica. Right on.
Nah, man, they're loyal as could be. They're always here.
Yeah. Yeah. So are you going to have Sal Paez on anytime soon?
Hopefully, actually, I've got Jeremy reaching out to him to ask for exactly that, as it is long overdue. And now that he seems like he's been allowed to go on a public social media private citizen talking tour again, as when we first were talking with them then there was about a year that it seemed like he had a gag order on him for a bit, but now that he's able to speak publicly again, just like you guys were discussing earlier with how well a job Ashton does, it's something I also take pride in coaxing topics and getting people to talk about things in manners that don't violate NDAs while giving the technical information references for those that know and can make use of the information, right?
Yeah. Ashton knows how to dance, bro. He does.
Absolutely.
He does. The only thing about it, though, is that it's like when you do the dance, it's like, we can't. It's like, because the guys that come up with this stuff, like, they came up with it because they're smart guys, too. So it's rough,
Yeah.
It's reading in between the lines. It gets you so much further half the time with it, because they'll say a lot of the quiet parts out loud as long as it's not in context, as long as it wasn't asked, as long as it's pertinent to an exterior sidebar conversation relevant to the
as long as it's referenced that it's only LARPing and has to do with the yoke craft that the average will just take as a joke, when in fact it's advanced real science and technology and engineering being disclosed.
Yeah, everything's starting to sound like such a lie anyway. Like, it's so out there that reality is so much stranger than fiction.
Yeah.
That you get away with saying the stuff and people would just shake their head and roll their eyes, but then they don't even realize they're on their smartphone and they're getting like a live video from the other side of the planet that bounced off of 4 servers instantaneously, and then conversing with other people throughout the globe, and it's in the palm of their hand, and they didn't have to charge it since last night. And it's like, where do you think any of this stuff came from? If this isn't magic to you and you doubt any of the silly things that we're saying because it all has to do with wave function that's a little less tangible, like, well, that's on you. But you're holding it in your hand, pieces of it, a lot of it.
Right, exactly. And that it's all compartmentalized and it's all trade secrets / NDAs. But when you get to the nitty gritty of it and the actual patents and publications, it's all laid out in the open.
Yeah, this is like a cooking recipe where you could give the person all the right ingredients, but come up with 20 different dishes, or come up with dishes that don't work at all because you didn't put the stuff in the right sequence.
I've seen a lot of that today.
That's what it comes down to. So you can know exactly what it is and exactly what it takes, but unless if you put the right amount in the right order,
don't know the amount of
right
yeast
time,
and when to put the yeast in, you're just going to end up with flatbread and an infection that you don't want, right? So
that's exactly it. That's exactly it. Yeah, that's why you got to temper your eggs, right? If you don't temper them, then you just end up with scrambled eggs inside your yuck. For real. So.
Yeah, they keep trying to get us like with that pipe experiment, and they tried to get us with the egg, and God knows what's next coming down the line. I mean,
well, it's cooking omelets for the mass media that they need to be pipe fed because, or the mass population, because you can't just give the lemmings everything at once and collapse their narrative and let them know that their whole reality construct is based off of falsities and lies. You just got to slowly feed it day by day. And it's like now at least the discussion is, oh, there's something massive under the pyramids. It's probably not a tomb and it's probably much older. And then it's like, oh, at least free energy is real. So whether it's just this small little pipe that you can't get anything out of for the average person that replicates the experiment, thus nobody's going to actually that verifies it going to be able to build something that powers their homes. But from the understanding and eventual application, groups like ours, individuals ahead of the curve, it's the foundation for what we're working on to become mainstream in the very near future. And that's exactly what we need, and exactly the way to hijack the narrative, take control through disclosure of technology and science.
oh, see, we won't get ahead because we didn't agree with their experiments. See, they only promote those who agree with it. So if we all agree with the pipe, we get ahead. We don't agree with it.
Yeah,
I think the craziest part about it, though, it's not even the free energy aspect or anti-gravitics. At this point in time, that's just technology, and like we're used to new technology all the time. Like things that were impossible 10 years ago are possible today, and so on and so forth. So new technology isn't really the shocker. The shocker is the implications of where it's all coming from, because the reality of reality is the shocker.
Yeah.
Because what the implication of the tech means is that there's something on the other side of this, definitely, and you don't have and go to church, because that's a good thing, but you don't have to go to church for it to believe in it, or it exists, it scientifically exists at that point. And the whole idea of faith being intertwined in it is the most, the idea of faith being intertwined with it is the most dangerous aspect of it. Trust me. You see what happens when people don't agree on faith. What happens when you tell everybody that their faith is all the same?
Well, so I have a little bit different view of it, that everyone's faith should be, you focus on the good side of your beliefs and wanting to achieve the angelic, and you avoid the demonic, the djinn, the Satan, whatever. And that's all that matters, as long as you're focusing on positive instead of the negative.
Oh, listen, Bernie, I'm not going to disagree with you, but I'm pretty sure there's like millions upon billions of people that literally walk around a cube in the middle of the desert that probably be a little resistant to these ideas.
As long as and others, and an angel that comes out, I have no problem with it. It's only when it comes to that inverted demonic side that comes out that we got issues. And I know I'm getting a little esoteric and occult, but it's intertwined with the alchemy, and the further you dive into that rabbit hole, that's a conversation.
Right. I mean, we try not to have that be a main focus of the things we talk about, but Nathan and I have done countless episodes on how this is all tied together and intertwined, and I think that that's one aspect of it that needs to be recognized. It's probably the least talked about of them all, and even like Ashton, who does a great job covering the implications and the possible reasons for non-disclosure and why disclosure is going to happen and how it's going to happen. One of the implications is the faith aspect of things, and the implications of that, what that would mean for society by and large and as a whole. It's crazy. So
I have faith that the most evil motherfuckers out there that already control these weapons and technology and information haven't killed us yet. So the average individual and every individual having the ability and knowledge to turn water into isotopes and fuel and nuclear products, that it will benefit humanity and will not destroy us, and it will just elevate us to the next level. And
Hey, listen, I'm on board, right?
Exactly, and that's why it needs to happen, and it needs to happen fast. And sure, there's going to be some individuals that blow themselves up accidentally or intentionally and take some people with them, but the overall will build beautiful things and be able to, get into other dimensions and planets and planes of existence and so much more, that you got to take the wins with the losses, and that's all there is to it.
Yeah, well, right. It's like Christopher said. We must join as one. Together, we must cross the river. Right. That's.
Yeah. I just want to say thank you to Sean. And by the way, guys, we only get in trouble when regular human beings try to take the place of God, or act like a god, or have powers like one. And there's several of them out there that think that they're untouchable deities in certain religions. And that's the problem we're coming up against. It's them that hold us back. Those are the individuals that are doing it. And they cover for all their buddies and screw up the world. So, they know who they are. So, anyway,
you are. We talking to you.
Going into that a little bit more, we're going to have Liz on again. And since that whole pyramid thing and all the stuff underneath it, and then she's got like a whole thing on it that she does, and she's actually really good with Egypt and the stuff that they're doing there. She's like an expert in the Egypt tech, man. So I'm really excited. She's going to be on.
Yeah, man, she's hot on that topic. I can't wait for that.
Yeah, I gotta catch up on that series. You got 3 or 4 with her now, right? It'll be the 3rd or 4th.
We have 2 of them on there right now, and I'll be honest with you, Bernie. I set aside those videos and I actually cut them so that we can do the look back on the people that came on the channel.
Nice, perfect. The review show for show.
So there's 3 of them, and it's like 2-hour things, but I split them up so that we can stop in between, and have them segmented.
All right, well, let's schedule that for sometime this week. Let's get that done. I'm looking forward to that.
And then that scalar physics video, man, we'll have to get together, all 3 of us, and do that. That one's awesome. Right, Joe? That was a good one.
Definitely, it was great, man. Definitely the more minds on that one, the better, because it's such a simple topic, except it's extraordinarily difficult to articulate. So, yeah, we try our best.
I like it, and it needs to happen. And there's a lot of misperceptions on scalar and misclassifications as well, right? So, let's maybe aim for that this weekend.
Yeah, if you're up for it, I'm in.
For sure. Yeah.
Dude, there's a lot of good stuff coming up, man. I'm excited. By the way, I started a podcast channel.
I saw that.
Yeah. Dude, I just thought it was so cool. Yeah, thank you. I hope everybody does. I changed everything to 9:16, so you can watch it on your phone and just listen to it. So nice. One of the coolest things was I uploaded my theme song for Old Man Builds, and then I was able to pull it up on YouTube Music for podcasting and play it in my truck, dude. So I'm rolling down the road listening to Old Man Builds in my truck, fucking going off. Dude, it was so awesome.
That is. You're gonna have to show me how to do that.
Nothing better than driving down the road playing your own theme song, bro.
Yeah. Hey, yeah. I put yours in there too, Joe.
Hell yeah.
Nice. Very nice.
So, no, but it was cool because now cutting shorts is so much easier to do. Like, I literally reframe it, and then once I get done reframing it, I go through and cut 4 shorts out of it. And man, it's no time at all, and it looks nice and clean.
Yeah, it's getting easier and awesome, and we're also developing skills, right? If anyone wants to, hire out old Bernie or Nathan for video editing there, graphic design. Just kidding.
Oh, I don't work that hard.
I know, I'm just kidding. We're so busy on our own stuff. It's like, good luck.
Yeah. I always have to turn down stuff, man. I'm not into all that. I was retired before this, so
Right.
you know what I
Welcome
mean?
back to the workforce. How's your
Yeah.
slave labor or slave wage from YouTube treating you?
Oh my God. I make in 1 month what I would make in an hour.
Right?
You know what
Yeah.
I mean?
Exactly.
Sure.
Exactly. Straight
And
up.
I put in a lot more hours here than I do anywhere else. But you know what? Honestly, man, I do it for I just do it for the love
Labor
of
of
it, man.
love. Labor of
Yeah.
love.
That's it. Even though it's the most frustrating thing ever. So
I think it's great. You guys are wonderful.
yeah, Joe gets to just talk about it.
Yeah,
That's
I don't do
awesome.
shit. I just show up.
Hey.
He's
pre-COVID,
retired and
Joe.
I'm retarded, and together we're a team.
Two retards and an old man. Sounds like a band.
Yo, now that's a show.
There you go.
That's the show right there. All
That's
right.
the show,
All
man.
right.
All right.
Oh my God, dude, that's so going in the Star Trek episode. I'm so behind on that. I
Right,
really
exactly.
need to make another one.
Yes, please.
That was so funny last time, though. You know, those things are great. I was watching Mushrooms here just a week ago, man. That was the best episode
That
ever.
was one of my faves.
And then I was cutting the shorts for Joe's Rock, and all the same phrases came up in it. And I'm like, dude, I can't get over it, man. I put them on the shorts too.
Well, since all the shorts, you can't unhear it when it's played. You know, you can't listen. I think my favorite episode was either Jeremiah, that episode, or the Schmucks. I that one was good too.
The Schmucks is good.
Schmucks was good. Got Jack in there, man.
I
When
didn't
his face
even make
would
up
change from
anything.
this angle to that angle, like I was lost it, man.
It's a classic all in its own. And
Yeah.
man.
Oh
Yeah.
man.
If you've been a viewer for months and months, you know exactly what we're talking about.
Oh yeah. Oh man, the best was when Bernie came on and he goes, I was tripping on mushrooms by tripping on the show. You know, it was the best. He was tripping.
Yeah, for real.
Well, like, I don't do it often, but when it's meant to be, synchronicity happens and it works out, right?
Oh, it
Oh,
so
man.
does, man. Oh, that's so great. Yeah. Dude, that was so cool. Because Joe, what was that other lady's name that's gonna come on and do the Linus with us?
Right. So Eighth actually hooked us up with Gail as well. So we're gonna have an episode with Gail. They also have past life experience with Atlantis also. Same sort of memory, you know, of the past life. But what was interesting about Gail is that she was in the third era of Atlantis, and Liz was really the first and the second. So Gail actually bridges this gap that Liz does not recall. So that'll be interesting.
I find that fascinating, actually, with the different eras of it. Look forward to it. So yeah, we got a few shows we got to do in the next week.
Well,
and
we should get together and just have a show on that once we get these done, because there'll be like 4 episodes in, and then we'll do like a weekend thing on it, man, because it'll trip you out, all the different questions we ask and how much it matches the technology and everything that we're looking at in the future. Dude, it is like mind-blowing, because all of it matches, from the crystals and resonance and all this stuff, and how it matches exactly where we're going in science. And then you're like, you get to the realization of, we've already been here before. And that's the most mind-blowing thing when it comes out, because it's like, I can see that.
So that just like that's I think gonna be a key part of when the singularity happens is like everyone's just gonna connect with all of their memories of their previous lives as well, right? It's like you're not just gonna become telepathic, you'd be like, oh my god, I've lived this before. And
Right, that's what happens when you cross into the there that I'm talking about all the time. When you're not here and you're there, then you just have the full access, you know. What's crazy is when you come back to the physicality and the perspective that I'm kind of talking about, the context I'm talking about, when you really only wormhole back with so much out of it. You can't bring it all back with you, you know. So yeah, the singularity, that's exactly that exists there, not here.
Oh wow. We're all gonna face it one day, huh?
oh,
Drop us a woo if you got them.
and I
Oh, do I have that? Oh, hold on. Here we go.
Hey, it's officially Woo Woo Wednesday. 555 in Alberta right now. But yes, connecting your mind to the woo, aka Akashic record or cosmic intelligence source, whatever you want to call it. But like Joe was just saying, there's only so much you can bring back with you. And when you're made in that connection, in that moment, you try to write it down, you try to explain it. I literally have like writings of myself writing, this sounds crazy, there's no way this makes sense, like writing in circles, just like the craziest things of like, but in the moment it's like you're connected, you can visualize it all, and it's a matter of recalling it afterwards, then putting it down into a coherent explanation and testing it and bringing it all together.
That's the way.
You
ever have an 80-pound lapdog before?
Ooh, what now?
So, you ever have an 80-pound lapdog?
Oh God, I've got 121, but
oh, nice. That's a big boy.
Upstairs with Grandpa, but what a beautiful, beautiful boy. Pity or girl?
He's
girl
a good boy. He's a boy. His name's Mac.
Oh, what a Mac! I love it.
Yeah, like a truck.
Mac truck.
Bam. Yeah.
Oh, he loves his dad.
Yeah, he does. I think he wants to go out or eat or some shit. Who knows? It's very simple needs.
Right? Are you guys wearing matching shirts, you and Mac? Because that's
yeah, pretty much. Yeah, he's wearing a vest.
Amazing.
He's a service dog, or else I couldn't keep him where I live. Thank you, federal laws. I've exploited you one time. Yeah, he's a little over the 25-pound weight limit that they have at this place.
Oh, good thing he's a service dog.
Damn right.
Love it.
Bring you on a plane with me, buddy.
I didn't even think of that. I'm gonna have to register my T2 now. But on that note, love you guys. Pleasure catching up. I've got to run, go pick up Amber from her cleaning job here. So we will see you again, hopefully Friday, if not sooner. Well, yes, Thursday. But if we don't see you tomorrow, we'll see you Friday. Much love.
Sounds good, Bernie.
Thanks for having me on.
Thank you, Bernie. I really appreciate you showing up, man. Right on.
Always a pleasure.
We'll see you on the weekend, man. We'll do a cool show.
We'll have to do a weekend at Bernie's.
That's right.
Right.
All right.
Right on, man.
Good times, man.
Oh, yeah. Always good, man. Oh, man. I saw that one guy in the chat. Oh. Guy frustrates me. Anyway, I'll move on.
always let him get on your nerves, bro.
The biggest troll in the world, dude. Comes over and dislikes every video that I do. What a troll. Oh,
Yeah.
right
That
on,
fucking
Bernie.
piece of shit.
It's about not Bernie. We're talking about somebody else.
No.
He's like, I'm leaving. I said, good. Get out. Don't need you. Not Bernie, the other guy. Oh man. Oh, that's just bad to say, isn't it? I apologize. Not really. That guy needs to go.
Sorry, not sorry.
Yeah, not sorry about that.
Yeah.
The total turd in the punch bowl. Had to go. Baby Ruth in the pool had to clean it out.
The things I would say if I didn't care about people.
Oh yeah. Sorry. I pretty much like everybody, man, except for that guy.
Shit stabbing son of a bitch. All right, we've derailed. It's 3 hours. That's exactly when we always derail.
Oh yeah. Usually, well, after the first hour, it just goes sideways, and then yeah, it totally derails anytime you get past the third hour.
Hey, I'm proud of us. We kept it together with Bernie on. That's hard.
Oh, you know what? Bernie, let's play the Star Trek, man. Which one?
It's so easy to go off the rails when Bernie's on.
Oh man. All right, let me find it. Where's it at? Oh, it's so long ago on my list. All right. Oh, okay, which one do you want, Joe? You want the last one? Or you want to do the mushrooms, or you want Jack?
Yo, let's do Jack, bro. Yeah. It's been a while.
Okay.
I was gonna say run the Jeremiah, but maybe don't run the Jeremiah.
Yeah, we're not doing that. I'm not getting in trouble. Well, nothing to do with that.
Yeah, that's fair.
This is
Don't make
Captain
mistakes.
speaking. Can I please have everybody assemble at the view screen? Admiral Jack would like to address everybody at once. Admiral Jack, would you like to address everybody?
All these wannabe schmucks, they have a keyboard and they can get on the internet, so that suddenly they're experts.
Did he just call us all schmucks?
Schmuck.
Schmuck.
You're not a schmuck.
I was microdosing mushrooms that day. Not today, but that day I was.
Admiral Jack, we tried to get our transporters fixed. We reached out to the physics community for help. What do you think about it?
I think they're idiots. I think that when it comes to physics, okay, they don't know what the fuck they're talking about. And anybody who pays any attention to them, gives them any credibility, is stupider than they are. That's what I think.
Oh, man, those people in physics sure didn't rub Jack the right way.
Given a chance, Jack will rub your grandma in the right way. Don't you worry about that.
Don't rub your grandma the right way.
Oh yeah, I agree. I totally agree.
It's all bullshit. It's all bullshit, okay?
Admiral Jack, maybe you can help us out with another thing. Joe tried to cook his hot dogs in the warp drive, and he screwed up something with the mass.
And he's made some very elementary mistakes. He violates Einstein's equation equals mc squared. He doesn't know the difference between the mass and the gravitational field, that the weight of an object is W equals mg.
You all heard the Admiral. Let's get this toroid out and let's get everything fixed.
Well, just an example, the inside of the toroid, that's about 3-inch diameter, 3.5-inch diameter.
Was I right to say it's about 6 inches in diameter altogether?
Yeah, maybe a touch bigger. Yeah.
It's an awfully big hole, Mike.
Don't go there.
It's Canadian. There's 3 holes.
All right, so you're gonna hook it up, and then we're gonna throw hot dogs through it like a carnival,
dude. Oh
my God, I'm choking.
This is what happens when you have me on. Don't we already know this?
Yeah.
At least Gerald has drawn the circuit for me.
Yeah.
Oh my God, we sound like a bunch of schmucks.
Schmuck.
Schmuck.
You're not a schmuck.
Don't tell me about what other schmucks say. Only I'm the big schmuck here, okay?
Oh, that was so great, dude.
Oh man, that was so overdue for a play. That was so overdue for a play.
Oh, a bunch of schmucks. That's so great.
You know, Bernie's interjections and that shit was so funny.
You rub your grandma the right way.
Rub your grandma the wrong way. Yeah.
Oh,
Right.
oh, oh my God.
Man. I remember that conversation with with Mike's big friggin' core. How big is that core? Throwing a hot dog down a hallway.
Oh, dude, he knew it was coming too. He knew it. He was all straight laced and talking about it. And dude, I couldn't help myself. I just had to go there.
Yeah.
Oh.
Yeah. A bunch of old people. That's what we are, bro. Just remember that.
Oh, what a schmuck. Oh.
Yeah.
Yeah, I'm gonna say we're all schmucks. Oh, that's so great, bro.
Yeah.
All right, Joe. Man, thank you for coming on and hanging out with me, man. It's so
Yeah,
awesome.
of course. You know, we all know that Sean has, you know, the best intentions to always get on here, and he puts the work in hard, and he can't always. So I'm more than happy to, you know, make your ears bleed and shit for a couple hours.
Dude, Sean's the best. The
best, man. Stand up.
Absolutely the best, yeah. And dude, the guy's smarter than smart. Let me just tell you that right now. I mean, who comes up with this stuff? I mean, that's just crazy.
Yeah, I mean, Ben Shapiro thought he was great.
Yeah. That was so awesome, Joe. That was a good one.
Oh, don't worry, more to come, but we could make them terrible. I could literally make them awful.
No, you did. You got to send Bernie the AOC one.
Oh yeah, that's right. I forgot I already did a couple. Yeah. Well, you'll send that one to Bernie for me. I'll send it to you again.
Yeah.
Terrible. Cannot play that on here. Sorry, guys. I don't even. Can that be on members only? That should not be on members only. Sorry, you'll just have to believe me. It's terrible.
Oh man, it's almost as bad as that organite butt plug. That whole thing was hilarious, and I still don't think I can play it live.
All right, well, I could summate this in PG. Look at this. So I did an AOC deep fake of her saying that she, you know, I don't really hate Trump, right? Yeah. So it's just think like Bill Clinton and Monica Lewinsky, except there was also Melania involved in the conversation.
So bad.
In explicit detail. Terrible. I love the internet, bro. 2025 for the win.
Yeah.
Make dirty AI memes.
Oh, what do you do in retirement? Oh, I just make dirty AI memes.
Such a righteous cause. What a summation to a life. You know what I mean?
So somebody's got to do it.
For real. And in his older years, he just made explicit deep fake AI memes.
Oh man.
I'm useless as tits on a bull, bro. Okay. I've laughed enough for 1 week.
Oh, I don't think so. We got a show in a couple days. Man.
That's right. Yeah, more. Two more days.
Oh man. All right, Joe. I think it's about time we end it, man. We had some good times today.
Amen, brother.
All right, guys, I want to thank everybody in the chat, man. Like I said, I got the new channel. Please check it out. And Joe and I will be back talking about something on Friday. Hopefully it's something
Leave your
good.
suggestions in the comments after the video post.
Right on, guys. With that said, I want to say thank you to everybody in the chat. You guys have been awesome. Thank you for Sean, for even though he couldn't come in the studio and do the presenting, he did it from the chat, which is totally awesome and cool of Sean. So thank you guys very much.
All right. Peace and love. Roll the creds.
The old man built. The old man built. The old man built. The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality been stricken from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds.